Hello there, and welcome. Tonight I want to take you somewhere special, somewhere far beyond the familiar glow of our earthly horizon, out into the vast, quiet depths of space where mysteries drift silently through the darkness. Settle in, make yourself comfortable, and let your mind begin to wander as we embark on a gentle journey together. A journey that will take us to the very edges of what we know, and perhaps, just perhaps, into the realm of what we can only imagine. Close your eyes if you wish, or let them rest softly on the darkness around you. Because tonight we're going to explore a question that might seem impossible at first, but one that grows more intriguing the deeper we allow ourselves to drift into its possibilities. It's a question that skeptics might dismiss as pure fantasy, but one that serious scientists have begun to whisper about in the quiet corners of observatories and research institutions around the world. What if the cosmic visitors that occasionally pass through our solar system aren't just random chunks of ice and rock wandering aimlessly through the void? What if some of them, maybe just a precious few, are something more deliberate, more purposeful? What if 3 Atlas, that mysterious interstellar object that graced our cosmic neighborhood, was programmed to track civilizations? Now, before you dismiss this as mere science fiction, consider this gentle thought with me. We live in a universe so vast that if you were to compress its entire 13.8 billion year history into a single day, our entire human civilization would occupy less than the final second before midnight. In that immense expanse of time and space, with billions upon billions of stars hosting potentially habitable worlds, is it really so impossible to imagine that somewhere, somewhen, an intelligence arose that decided to send out quiet messengers into the cosmic dark? Not aggressive probes, not conquering machines, but patient, silent observers, drifting through the millennia like seeds on a cosmic wind, waiting for the right conditions to reveal themselves. The story of 3i Atlas begins not with fanfare or drama, but with a quiet detection in the spring of 2020, when astronomers at the Atlas Survey System noticed something unusual moving through our solar system. At first, it appeared to be just another comet, one of countless icy wanderers that occasionally visit us from the outer reaches of our cosmic neighborhood. But as telescopes around the world turned their gaze toward this new visitor, something remarkable became apparent. This wasn't one of our local comets from the Oort cloud or the Kuiper belt. No, this object had come from somewhere else entirely, from another star system carrying with it the dust and memories of an alien sun. Think about that for a moment. Let that thought settle into your consciousness like a stone dropping into still water, sending ripples outward through your understanding. This object, this collection of ice and dust and perhaps something more, had been travelling through interstellar space for thousands, perhaps millions of years. It had witnessed the birth and death of stars, had passed through nebulae where new worlds were forming, had crossed the vast emptiness between solar systems where even light takes years to traverse. And somehow, through all that immense journey, it had found its way to us, to our small corner of the galaxy, at precisely this moment in our history, when we have the technology to detect it, to track it, to wonder about it. The designation 3i Atlas might seem clinical, scientific, devoid of poetry, but there's something beautiful in its simplicity. The 3i tells us this was only the 3rd confirmed interstellar object we've ever detected passing through our solar system. Think about that number for a moment. 3. In all of human history, with all our watching and waiting and wondering, we've only confirmed 3 visitors from beyond our sun's gravitational embrace. The first was Oumuamua in 2017, that strange, elongated object that sparked so much speculation and wonder. The second was 2I Borisov in 2019, a more conventional comet that nonetheless carried with it the chemical signatures of its distant home. And then came 3i Atlas, arriving like a quiet guest at a cosmic gathering, neither announcing itself loudly nor trying to hide. Perhaps what makes 3i Atlas so intriguing isn't just that it came from another star system. but how it behaved once it arrived in ours. You see, Brain, comets are usually predictable creatures. They follow the laws of gravity with mathematical precision, their paths through space determined by the invisible hands of celestial mechanics. We can calculate their trajectories years, decades, even centuries in advance. But 3i Atlas seemed to have its own agenda, its own subtle variations that made some observers wonder if we were witnessing something more than just passive physics at work. As we settle deeper into this contemplation, let your mind drift back to that spring of 2020, a time when the world was grappling with its own earthly challenges, when most of humanity was focused inward, dealing with a global pandemic that had changed everything about how we lived our daily lives. Yet above us, beyond the thin veil of our atmosphere, this cosmic visitor was making its approach, indifferent to our earthly concerns, following a path that had been set in motion long before our species even existed. There's something humbling in that thought, isn't there? While we worried about our immediate problems, the universe continued its ancient dance, bringing us a visitor from the depths of space, as if to remind us that we are part of something infinitely larger than ourselves. The Atlas system that first detected our mysterious visitor is itself a marvel of human ingenuity and patience. These telescopes, stationed in Hawaii and South Africa, scan the skies every clear night, taking hundreds of images, comparing them to previous observations, looking for anything that moves against the fixed backdrop of stars. It's like trying to spot a single grain of sand blowing across a beach by taking thousands of photographs and comparing them one by one. The dedication required for such work is immense, the patience almost meditative. Night after night, the astronomers and their automated systems watch, wait, compare, analyze, most of the time finding nothing more than known asteroids or the occasional new comet from our own solar system. But on that particular night when 3i Atlas first appeared in their data, something was different. The object's trajectory immediately marked it as unusual. While most comets in our solar system follow elliptical orbits that keep them bound to our sun's gravity, this visitor was on a hyperbolic path, a trajectory that meant it was just passing through, never to return. It was like watching a bird fly overhead and realizing from its flight pattern that it wasn't one of the local species but a rare migrant from a distant land, briefly gracing your sky before continuing on to destinations unknown. As word spread through the astronomical community, telescopes around the world began to turn toward this interstellar wanderer. Each observation added another piece to the puzzle, another data point in our understanding of what this object was and where it had come from. The Hubble Space Telescope, that magnificent eye in the sky that has shown us wonders beyond imagination, captured images of 3i Atlas as it approached the inner solar system. Ground-based observatories from Chile to Japan tracked its movement, measured its brightness, analyzed the light reflecting off its surface. It was a global effort, humanity coming together in a moment of cosmic curiosity, united in our desire to understand this visitor from beyond. What they found was both familiar and strange. Like many comets, 3i Atlas began to develop a coma as it approached the sun, that fuzzy envelope of gas and dust that gives comets their characteristic appearance. Solar radiation was warming its surface, causing frozen gases to sublimate directly from solid to vapor, creating a thin atmosphere around the nucleus. This was expected, normal, reassuring in a way. It suggested that despite its interstellar origins, this object was made of similar stuff to our own comets: water ice, carbon dioxide, perhaps some methane and ammonia, the basic building blocks that we find throughout our solar system. Yet there were subtleties in its behavior that gave some observers pause. The way it brightened and dimmed didn't quite match the models. The spectrum of light it reflected had unusual characteristics. And then there was its trajectory, that path through space that seemed to have brought it remarkably close to Earth, closer than probability alone might suggest. Of course, space is vast and coincidences do happen, but when you're dealing with an object that has travelled for potentially millions of years through the emptiness between stars, every small deviation from the expected becomes worthy of contemplation. Consider for a moment the sheer improbability of this encounter. Space, as Douglas Adams once noted, is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. The distance between stars is so immense that even travelling at the speed of light, it would take years to reach our nearest stellar neighbour. For an object moving at the relatively sedate pace of a comet, we're talking about journeys measured in hundreds of thousands or millions of years. The chances of such an object randomly passing through the inner solar system where Earth resides are infinitesimally small. It's like throwing a grain of sand from one continent and having it land in a specific teacup on another continent, except the scale is billions of times greater. So when we observe an interstellar object passing relatively close to Earth, it naturally raises questions. Are we simply lucky witnesses to a cosmic coincidence, or is there something more deliberate at work? The scientific method demands that we consider the simplest explanation first, that this is indeed just a random encounter, a fortunate alignment of trajectories that has allowed us to observe something rare and wonderful. But the scientific method also requires us to consider all possibilities, to test our assumptions, to remain open to ideas that might seem extraordinary but are not impossible. This is where our contemplation tonight takes a gentle turn toward the speculative, toward the realm of what might be. Because while we have no direct evidence that 3i Atlas was anything more than a natural comet from another star system, we also have to acknowledge the limitations of our observations. We detected this object relatively late in its passage through our solar system. We had only a brief window to study it before it continued on its journey back into interstellar space. Our instruments, magnificent as they are, can only tell us so much about an object millions of miles away. We can measure its brightness, analyze its spectrum, track its movement, but we cannot examine it directly, cannot touch it, cannot know for certain what lies beneath its icy surface. And this is where the possibility emerges, quiet and persistent like a whisper in the cosmic dark. What if 3i Atlas was more than it appeared? What if beneath that natural-seeming exterior of ice and dust there was something artificial, something designed? Not necessarily a spacecraft in the traditional science fiction sense, but perhaps something more subtle, more elegant. Imagine a probe designed to look exactly like a natural comet, programmed to behave like one, but carrying within its frozen heart sophisticated sensors and recording devices, patiently gathering data as it passes through star system after star system. The idea isn't as far-fetched as it might initially seem. We humans have already considered similar strategies for exploring the cosmos. Scientists have proposed using comets as vehicles for interstellar probes, taking advantage of their natural properties to protect delicate instruments from the harsh radiation of space. A comet's ice could serve as shielding, its outgassing could provide minor course corrections, and its natural appearance would make it indistinguishable from the countless other comets wandering through space. It would be the perfect camouflage for an artificial probe, hiding in plain sight among the natural debris of the cosmos. Think about the elegance of such a design. Rather than building massive, obviously artificial spacecraft that would announce their presence to any observer, an advanced civilization might choose subtlety. They might engineer probes that are virtually indistinguishable from natural objects, probes that could travel through space for millions of years without degrading, powered by nothing more than the occasional gravitational assist from passing stars and the patient ticking of atomic clocks. These wouldn't be probes designed for rapid exploration or aggressive investigation, but rather for long-term observation, for quietly cataloguing the emergence and development of life throughout the galaxy. The concept has a name in scientific circles, though it's spoken of only in hushed, speculative tones. It's called a Bracewell probe, named after the astronomer Ronald Bracewell who first proposed the idea in 1960. Bracewell suggested that rather than trying to communicate across the vast distances of space using radio signals that would take years or decades to travel between stars, an advanced civilization might send out autonomous probes that could wait in a star system for signs of intelligent life. These probes would be patient, perhaps waiting for thousands or millions of years, monitoring planets for the telltale signs of technology, for radio emissions, for the chemical signatures of industrial activity, for the lights of cities on the night side of worlds. When such a probe detected signs of a technological civilization, it might activate, perhaps sending a signal back to its creators, or perhaps attempting to make contact with the newly discovered intelligence. Or, and this is where our contemplation becomes even more intriguing, perhaps it would simply observe, gathering data about this new civilization, studying its development, its challenges, its potential, all while maintaining its disguise as a natural object. It would be the ultimate in non-interference, allowing civilizations to develop naturally while still maintaining a careful watch over their progress. Now, you might wonder, if such probes exist, why haven't we detected them? Why hasn't one made obvious contact with us? But consider this. If you were designing a probe to monitor emerging civilizations, would you make it obvious? Would you have it announce its presence the moment it detected radio signals or city lights? Or would you program it to be more cautious, more patient? Perhaps such probes are programmed to observe without interfering, to gather data without influencing the natural development of the civilizations they encounter. Perhaps they operate on timescales far longer than our brief moment of technological awareness, waiting for civilizations to reach certain milestones before revealing themselves, if they ever do at all. The timing of 3i Atlas's passage through our solar system is itself thought-provoking. It arrived just as our technology has become sophisticated enough to detect and track interstellar objects, but not advanced enough to intercept or closely examine them. We could see it, we could wonder about it, but we couldn't reach it. It's as if it passed through at exactly the right distance to be noticed but not investigated. Close enough to spark our curiosity, but far enough to maintain its mysteries. If you were programming a probe to make a subtle assessment of a civilization's technological development, this would be an ideal approach, wouldn't it? Close enough to be detected by a species that has reached a certain level of astronomical capability, but not so close as to be threatening or to allow detailed examination. There's something almost poetic in the way 3i Atlas began to fragment as it approached the Sun. In April 2020, astronomers observed the comet beginning to break apart, its nucleus splitting into multiple pieces that gradually drifted away from each other. To most observers, this was simply the natural death of a comet, the Sun's heat overwhelming the weak gravitational forces holding its icy body together. Comets do this all the time in our solar system, spectacular deaths that seed space with debris and dust. But what if this fragmentation was something more? What if it was a programmed response, a way of dispersing sensors throughout our solar system? Or perhaps a self-destruct mechanism to prevent the probe's technology from being discovered? Imagine for a moment that you're an engineer tasked with designing a probe that must operate for millions of years, traveling between star systems, observing without being observed. You would build in contingencies, wouldn't you? You would program it to respond to different scenarios, to protect its secrets if necessary. The fragmentation of 3i Atlas could have been entirely natural, the result of thermal stresses and gravitational forces, or it could have been the execution of an ancient program, a set of instructions written in a language we cannot comprehend, by minds that thought in timescales we can barely imagine. As we continue our gentle journey through these possibilities, let's consider what kind of civilization might create such probes. They would need to be patient beyond measure, thinking not in terms of years or decades, but in terms of geological and astronomical time. They would need to be curious but cautious, interested in other life forms but careful not to interfere with their natural development. They would need technology advanced enough to create probes that could survive millions of years in the harsh environment of interstellar space, yet subtle enough to disguise these probes as natural objects. Perhaps most intriguingly, they would need to have a different philosophy of exploration than we currently possess. Human space exploration has been driven by a desire for quick results, for dramatic discoveries, for the glory of being first. but the creators of probes like 3I Atlas, if indeed it was a probe, would be motivated by something else entirely. They would be cosmic gardeners, tending to the slow growth of intelligence throughout the galaxy, watching and waiting as civilizations rose and fell, gathering data across incomprehensible spans of time. This brings us to a profound question that deserves our quiet contemplation. If 3I Atlas was indeed a probe, what did it observe about us? What data did it gather as it passed through our solar system? Did it detect our radio emissions, the electromagnetic chatter of our civilization that has been spreading outward from Earth for the past century? Did it observe the lights of our cities on the night side of our planet, the telltale glow of a technological species? Did it note the changes in our atmosphere, the increase in carbon dioxide that marks our industrial age? Or did it gather more subtle information, data that our current science cannot even conceive of, measurements of qualities we haven't yet discovered, and perhaps more unsettling, or more wonderful depending on your perspective, what did it conclude about us? If there was an intelligence behind 3I Atlas, however artificial or distant, what story will it tell about humanity? Will we be catalogued as a young, promising civilization, still struggling with our planetary adolescence but showing potential for growth? Or will we be noted as a species at a critical juncture, balance between breakthrough and breakdown, our future uncertain? The thought that we might have been observed, evaluated, and catalogued by an intelligence far older and more advanced than our own is both humbling and inspiring. But let's not lose ourselves entirely in speculation. The scientific evidence we have about 3I Atlas is fascinating enough without embellishment. This object, regardless of its ultimate nature, has taught us valuable lessons about the interstellar medium and the exchange of material between star systems. By studying its composition, even from a distance, we've gained insights into the chemistry of other solar systems. The detection of certain molecules in its coma tells us that the basic building blocks of chemistry are similar throughout our region of the galaxy. Water, carbon, nitrogen, the elements essential for life as we know it, are not unique to our solar system but are spread throughout the cosmos. The trajectory of 3I Atlas also tells us something about the dynamics of our galaxy. By tracing its path backward, astronomers have attempted to determine where it came from, which star system might have been its home. The calculations are uncertain, complicated by the gravitational influences of countless stars over millions of years, but they suggest an origin in the general direction of the constellation Cassiopeia, perhaps from a star system hundreds of light years away. The object was travelling at about 26 kilometers per second relative to our Sun when it entered our solar system, a velocity that speaks to the immense energies involved in interstellar travel. Consider what that journey must have been like, even if 3I Atlas was nothing more than a natural comet. For millions of years it drifted through the darkness between stars, a frozen time capsule preserving the conditions of its birth. It would have been bombarded by cosmic rays, those high-energy particles that stream through space, gradually altering its surface chemistry. It might have passed through interstellar clouds of gas and dust, picking up or losing material along the way. It could have had close encounters with other stars, their gravity slightly altering its course, sending it on the path that would eventually bring it to us. During most of that journey, the object would have been in a state of deep freeze, its temperature just a few degrees above absolute zero. Any volatile compounds would have been locked in solid form, creating a pristine record of its origin. Only when it finally approached our Sun did it begin to warm, awakening from its long slumber. The ices began to sublimate, creating the coma that allowed us to detect it. In a sense, we were watching a message from another star system unwrap itself, revealing its contents through the spectrum of light it emitted. The fragmentation of 3I Atlas, which we mentioned earlier, provides its own set of mysteries and insights. When a comet breaks apart, it's usually because the stresses of solar heating overcome the weak forces holding it together. The nucleus, often described as a dirty snowball, is a loose aggregation of ice, dust, and rocky material. As the sun heats one side more than the other, thermal stresses build up. Pockets of gas form beneath the surface and burst through, creating jets that can spin the comet faster and faster until centrifugal forces tear it apart. It's a natural process, one we've observed many times with comets from our own solar system. But the way 3I Atlas fragmented was somewhat unusual. Instead of a gradual dissolution, it seemed to break into distinct pieces that then continued to fragment further. Each piece maintained its own trajectory, spreading out like seeds dispersed from a pod. Some astronomers noted that the fragmentation pattern didn't quite match their models, though they were quick to point out that our models are based on comets from our own solar system and might not apply perfectly to interstellar objects with different compositions or structures. This is where we must be careful to balance our speculation with scientific honesty. The unusual aspects of 3I Atlas's behavior could have perfectly natural explanations that we simply don't understand yet. Interstellar objects might have different structural properties than local comets, due to their long exposure to cosmic rays and the extreme conditions of interstellar space. The ices might be organized differently, the dust might be more or less cohesive, the overall structure might be unlike anything in our solar system. We're still learning, still gathering data, still refining our understanding of these cosmic wanderers. Yet it's precisely this uncertainty that makes 3I Atlas so fascinating. Every anomaly, every deviation from our expectations opens a door to new possibilities. Science progresses not by confirming what we already know, but by discovering what we don't. And 3I Atlas has shown us just how much we don't know about interstellar objects, about the exchange of material between star systems, and about the possibility of intelligence beyond Earth. As we settle deeper into our contemplation, let's consider the broader context of humanity's search for extraterrestrial intelligence. For decades, we've been listening to the cosmos, pointing our radio telescopes at promising stars, searching for signals that would indicate the presence of another technological civilization. This effort, known as SETI, the search for extraterrestrial intelligence, has so far yielded no confirmed detections. The cosmos remains stubbornly silent, at least in the radio frequencies we've been monitoring. This silence, often called the Fermi paradox after the physicist Enrico Fermi, is one of the great mysteries of our time. Given the vast number of stars in our galaxy, the billions of potentially habitable planets, and the immense age of the universe, it seems almost impossible that we're alone. Yet we see no evidence of other civilizations, no megastructures around distant stars, no obviously artificial signals, no visiting spacecraft. The universe appears empty of intelligence except for our own small corner of it. But what if we've been looking in the wrong way? What if, instead of broadcasting their presence across the cosmos, advanced civilizations choose a more subtle approach? What if they send out quiet probes, disguised as natural objects, to survey and catalogue the emergence of life throughout the galaxy? This would explain the silence while still allowing for the existence of extraterrestrial intelligence. They're not absent, they're just being discreet, watching from a distance, gathering information without interfering. The idea has profound implications for how we think about our place in the universe. If 3I Atlas and objects like it are indeed artificial probes, then we're not alone, but we're also not yet ready for direct contact. We're being watched, studied, evaluated, but from a distance that maintains our independence and allows our natural development. It's a cosmic version of the Prime Directive from Star Trek, a policy of non-interference that allows civilizations to grow and develop on their own terms. This perspective transforms the passage of 3I Atlas from a simple, astronomical event into something far more meaningful. It becomes a gentle reminder that we might be part of a vast community of intelligence, even if we're not yet aware of it. It suggests that our actions, our choices, our development as a species might have implications beyond our own world. We're not performing for an audience exactly, but our progress might be noted, recorded, remembered by intelligences far older and wiser than our own. Of course, we must also consider the alternative possibility that 3I Atlas was exactly what it appeared to be, a natural comet from another star system, remarkable for its interstellar origin, but otherwise unremarkable. This possibility is no less wonderful when you think about it. Even as a natural object, 3I Atlas represents a physical connection between star systems, a tangible piece of another sun's family that briefly visited our own. It reminds us that the stars are not isolated islands in space, but part of a connected galaxy, where material and perhaps even life can travel between worlds. The detection of 3I Atlas and other interstellar objects also tells us something important about our own capabilities. We've reached a level of technological sophistication where we can detect and track objects from other star systems. We can analyze their composition, calculate their trajectories, and even speculate about their origins. This is no small achievement. For most of human history, the stars were mysterious lights in the sky, beautiful but unknowable. Now we can detect visitors from those distant suns, study them, learn from them. We're becoming active participants in the cosmic conversation, even if we're still learning the language. As our contemplation of 3I Atlas continues, let's consider what its passage means for the future. If interstellar objects pass through our solar system regularly, and we're only now developing the ability to detect them, what else might we discover in the coming years? Each new interstellar visitor will add to our understanding, providing more data points, more opportunities to test our theories. Perhaps one day we'll detect an interstellar object early enough to send a probe to intercept it, to study it up close, to finally answer the questions that 3I Atlas has raised. There are already plans for such missions. Scientists have proposed spacecraft that could chase down interstellar objects, using powerful rockets or solar sails to match their tremendous velocities. These missions would be challenging, requiring us to detect the objects years in advance and launch spacecraft on precisely calculated trajectories. But the scientific rewards would be immense. To actually touch a piece of another star system, to analyze its composition in detail, to search for signs of artificial construction or modification, would revolutionize our understanding of the cosmos. Some researchers have even suggested that we might find more than we bargained for. If interstellar objects are sometimes artificial probes, then intercepting one might trigger a response. Perhaps the probe would activate, recognizing that the civilization it was monitoring had reached a level of technology sufficient for contact. Or perhaps it would self-destruct, its programming designed to prevent its technology from falling into the hands of a species not yet ready for such knowledge. These are speculative thoughts, of course, but they illustrate the profound implications of our growing ability to interact with interstellar visitors. The story of 3I Atlas also highlights the importance of continued vigilance in our observation of the skies. The Atlas system that detected it was designed primarily to search for potentially hazardous asteroids that might impact Earth. The discovery of an interstellar object was a bonus, an unexpected gift from a program focused on planetary defense. This reminds us that scientific discoveries often come from unexpected directions, that instruments built for one purpose can reveal wonders we never anticipated. As we move deeper into the 21st century, our ability to detect and study interstellar objects will only improve. New telescopes, both on the ground and in space, will scan the skies with unprecedented sensitivity. Machine learning algorithms will sift through vast amounts of data, identifying unusual objects that human observers might miss. We might discover that interstellar visitors are more common than we thought, or we might find that each one is unique, carrying its own story from a distant star. The possibility that some of these objects might be artificial adds an extra layer of excitement to these future discoveries. Each new interstellar visitor will be scrutinized not just for what it can tell us about other star systems, but for any signs that it might be more than a natural object. Scientists will look for unusual trajectories, unexpected accelerations, anomalous compositions, or any other hints that might suggest artificial origin or modification. It's a search that requires both rigorous skepticism and open-minded wonder, a balance that characterizes the best of scientific inquiry. As we contemplate these possibilities, it's worth remembering that the universe has a way of surprising us. Many of the greatest discoveries in astronomy were unexpected, revealing aspects of the cosmos we hadn't even imagined. The discovery of pulsars, the cosmic microwave background, dark energy, and gravitational waves all came as surprises, forcing us to revise our understanding of the universe. Perhaps the true nature of interstellar objects like 3I Atlas will prove equally surprising, revealing something about the cosmos that we haven't yet conceived. The passage of 3I Atlas through our solar system in 2020 was brief in astronomical terms, just a few months from detection to departure, but its impact on our imagination and our understanding of our place in the cosmos continues. It has joined Oumuamua and 2I Borisov in a small but growing catalogue of confirmed interstellar visitors, each one adding to our knowledge, each one raising new questions. These objects are like messages in bottles, cast into the cosmic ocean by distant stars, washing up on the shores of our solar system for us to discover and ponder. Whether 3I Atlas was a natural comet or something more mysterious, its visit has enriched our understanding of the universe. It has shown us that our solar system is not isolated but part of a galactic community where objects can travel between stars. It has demonstrated our growing ability to detect and study such visitors. And it has sparked our imagination about what else might be out there, drifting through the darkness, waiting to be discovered. As we prepare to move into our next phase of contemplation, let's carry with us the sense of wonder that 3I Atlas has inspired. Let's remember that we live in a universe full of mysteries, where even a chunk of ice and dust can carry profound implications for our understanding of existence. Let's remain open to possibilities, both natural and artificial, that might explain the cosmic phenomena we observe. And let's appreciate the privilege of living in an age where we can detect and study visitors from other stars, even if we cannot yet fully understand their nature or purpose. The journey of 3I Atlas continues even now, as it speeds away from our sun back into the darkness of interstellar space. Its trajectory will carry it onward for millions more years, perhaps to visit other star systems, perhaps to be detected by other civilizations who will wonder, as we have, about its nature and origin. It carries with it, in a sense, a record of its brief encounter with our solar system, its surface slightly altered by the sun's heat, its composition slightly changed by its passage through our neighborhood. In this way, we have left our mark on an interstellar object, just as it has left its mark on us. Now, as we continue our journey through the cosmic mysteries surrounding 3I Atlas, let us turn our attention to the remarkable trajectory that brought this enigmatic visitor through our solar system. The path of an object through space tells a story, written in the language of physics and gravity, a story that can reveal not only where it came from, but perhaps even why it came at all. Every deviation, every subtle change in velocity or direction becomes a clue in our cosmic detective story, a hint about the true nature of our interstellar visitor. The trajectory of 3I Atlas was hyperbolic, a mathematical term that carries profound implications for our understanding of this object. Unlike the closed elliptical orbits that keep our planets circling the sun year after year, a hyperbolic trajectory is open-ended, a one-way journey through our solar system with no return. This immediately marked 3I Atlas as a visitor from beyond, an object not bound by our sun's gravity but merely passing through, like a traveller briefly stopping at a way station on a much longer journey. To truly appreciate the significance of this trajectory, we need to understand something about the delicate dance of gravity that governs all movement in space. Every object in the universe pulls on every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. It's a simple law, discovered by Newton over 3 centuries ago, but its implications are infinite and beautiful. This law determines the orbits of planets, the paths of comets, the structure of galaxies, and yes, the trajectory of interstellar visitors like 3I Atlas. When an object approaches our solar system from interstellar space, it enters what astronomers call the Sun's sphere of influence, a region where our star's gravity becomes the dominant force. The size of this sphere is enormous, extending roughly 2 light-years from the Sun, encompassing not just the planets, but also the vast Oort cloud of comets that marks the outer boundary of our solar system. As 3I Atlas entered this sphere, probably thousands of years ago, the Sun's gravity began to bend its path, pulling it inward, accelerating it toward the inner solar system where we would eventually detect it. The specific path that 3I Atlas followed through our solar system was not random, but determined by its initial velocity and direction as it approached. Think of it like rolling a marble past a depression in a sheet. If the marble is moving fast enough and doesn't pass too close to the center of the depression, it will curve around it and continue on, its path bent but not captured. This is essentially what happened with 3I Atlas. It approached our solar system with enough velocity to avoid capture, curved around the Sun, and continued on its way, like a cosmic marble rolling past a gravitational depression in the fabric of space-time. But here's where things become intriguing. The exact trajectory that 3I Atlas followed brought it remarkably close to Earth, at least in astronomical terms. It passed within about 0.4 astronomical units of our planet, where 1 astronomical unit is the average distance between Earth and the Sun. To put this in perspective, that's closer than Venus at its nearest approach, close enough that if 3I Atlas had been significantly brighter, it might have been visible to the naked eye. For an object that had been travelling through interstellar space for potentially millions of years, to pass this close to a habitable planet seems almost too convenient to be mere coincidence. Now, space is vast and coincidences do happen. Objects following random trajectories will occasionally pass close to planets purely by chance, but when we calculate the probabilities, the numbers become thought-provoking. The volume of space within our solar system is enormous, and the planets occupy only a tiny fraction of it. For an interstellar object to pass within 0.4 AU of Earth, especially Earth which orbits in the narrow habitable zone where liquid water can exist, the odds are quite small. Not impossible certainly, but small enough to make us wonder whether there might be more to this trajectory than simple chance. Let's delve deeper into the specifics of 3I Atlas's path. The object approached our solar system from the direction of the constellation Cassiopeia, travelling at approximately 26 kilometers per second relative to the Sun. This velocity is typical for objects in our region of the galaxy, suggesting that 3I Atlas had not been dramatically accelerated by a close encounter with another star, at least not recently. As it fell toward the Sun, it accelerated, following the inevitable pull of gravity, reaching its peak velocity at perihelion, its closest approach to our star. The perihelion of 3I Atlas occurred on May 31, 2020, when it passed within 0.25 astronomical units of the Sun, roughly the same distance as Mercury's orbit. At this point, it was travelling at approximately 66 kilometers per second, screaming through the inner solar system at a velocity that would carry it from Earth to the Moon in less than 2 hours. The Sun's heat at this distance was intense, causing the ices in 3I Atlas to sublimate rapidly, creating the bright coma that made it visible to our telescopes. It was during this close approach that the object began to fragment, breaking into multiple pieces that would continue to puzzle astronomers. After perihelion, 3I Atlas began its long journey back to interstellar space, gradually decelerating as it climbed out of the Sun's gravitational well. But here's where observers noticed something unusual. The trajectory of the fragments didn't exactly match what models predicted based on gravitational forces alone. There seemed to be small but measurable deviations, what astronomers call non-gravitational accelerations. These are typically caused by outgassing jets of vapor escaping from the comet's surface that act like tiny rockets, pushing the object in unexpected directions. Non-gravitational accelerations are common in comets from our own solar system, and astronomers have developed sophisticated models to predict them based on a comet's size, composition, and rotation. But with 3I Atlas, the models didn't quite work. The accelerations were there, but they were subtly different from what was expected. Some fragments seem to experience stronger accelerations than others, despite appearing to be similar in size and composition. The timing of the accelerations didn't always correspond with the object's distance from the Sun in the way that simple outgassing would predict. These anomalies led some researchers to consider alternative explanations. Perhaps the composition of 3I Atlas was different from our local comets, in ways that affected its outgassing behavior. Perhaps its long journey through interstellar space had created an unusual internal structure that caused it to fragment and accelerate in unexpected ways. Or perhaps, and this is where we venture into more speculative territory, the accelerations were not entirely natural. Consider for a moment what it would mean if 3I Atlas could make small adjustments to its trajectory. Not large, obvious course changes that would immediately reveal its artificial nature, but subtle modifications that might be attributed to natural processes. Such capability would allow a probe to fine-tune its path through a solar system, ensuring it passed close enough to interesting planets to gather data while maintaining the appearance of a natural trajectory. It would be the perfect balance between investigation and camouflage. The fragmentation of 3I Atlas adds another layer to this trajectory mystery. When the object broke apart, each fragment followed its own path, spreading out like a shotgun blast through the inner solar system. From one perspective, this was simply the death throes of a comet unable to withstand the sun's heat. But from another perspective, it was an efficient way to survey multiple regions of our solar system simultaneously. Each fragment became its own independent observer, gathering data from a different vantage point, creating a three-dimensional map of our cosmic neighborhood. The timing of the fragmentation is also intriguing. It began just as 3 Atlas was passing through the region of space where it could observe Earth most clearly, where our planet's atmosphere, surface features, and potential biosignatures would be most visible. If you were designing a probe to study potentially habitable worlds, you might program it to deploy multiple sensors at just this point, maximizing the amount of data gathered while maintaining the appearance of natural fragmentation. We must be careful here not to let our imagination run too far ahead of the evidence. The fragmentation of 3I Atlas could have been entirely natural, and probably was. Comets are fragile objects, held together by weak forces, and many of them break apart when exposed to the sun's heat. The unusual aspects of 3I Atlas's fragmentation might simply reflect our incomplete understanding of how interstellar objects behave. We've only observed 3 such objects so far, hardly enough to establish patterns or norms, yet the possibility remains, hovering at the edge of our consciousness like a half-remembered dream. What if the trajectory of 3I Atlas was not entirely random? What if its path through our solar system was influenced, however subtly, by something more than gravity and outgassing? The evidence is not conclusive, but it's suggestive enough to keep us wondering, to keep us watching for the next interstellar visitor, to keep us refining our models and our understanding. As we contemplate these possibilities, let's consider what we might learn from future interstellar objects. Each one that passes through our solar system provides another data point, another opportunity to test our theories about their nature and behavior. If we find that interstellar objects consistently pass closer to Earth than probability would suggest, that would be significant. If we observe more unusual fragmentations or unexpected accelerations, that would add weight to our speculations. Or if we find that everything can be explained by natural processes, that too would be valuable knowledge. The trajectory of 3I Atlas also raises questions about where it's going. As it speeds away from our solar system, it will eventually enter interstellar space again, returning to the cold, dark void between stars, but its path has been altered by its encounter with our Sun. It's now heading in a different direction, toward different stars, carrying with it any data or observations it might have gathered during its passage through our neighbourhood. Astronomers have attempted to calculate where 3I Atlas might be headed, but the uncertainties are large. Over millions of years, even small errors in our measurements of its velocity and direction compound into huge uncertainties in its future position. It might pass through another star system in 100,000 years, or it might wander the galaxy for millions of years before its next encounter. If it is indeed a probe, this uncertainty might be intentional, a way of randomizing its path to ensure broad coverage of the galaxy over cosmic timescales. The idea of objects wandering between stars for millions of years, occasionally passing through solar systems, observing and moving on, has a poetic quality that transcends the mere mechanics of orbital dynamics. It suggests a galaxy that is more connected than we might imagine, where information and perhaps even intention can travel between stars on timescales that dwarf human experience. It transforms the cold equations of celestial mechanics into something almost purposeful, almost alive. This brings us to consider the broader implications of directed trajectories. If some interstellar objects are guided, however subtly, then the galaxy becomes a much more interesting place. It suggests a network of observation and information gathering that spans light years and eons. It implies patience and purpose on scales we can barely comprehend, and it means that our solar system, our Earth, our civilization, might be part of a vast catalogue of worlds, each observed and recorded by passing probes. The trajectory of 3I Atlas through our solar system lasted only a few months from our perspective, a brief moment in the cosmic dance. But if we zoom out, if we consider its entire journey from its origin to its distant future, we see something much grander. We see an object that has witnessed the birth and death of stars, that has passed through regions of space we can only observe through telescopes, that has carried the dust of distant worlds through the void. Whether natural or artificial, 3 Atlas is a messenger from the cosmos, and its trajectory through our lives, however brief, connects us to the greater galaxy in a tangible way. As we've traced the path of 3I Atlas through space and time, we've seen how trajectory can tell a story. The specific path an object follows, the subtle deviations from expected behavior, the timing of its closest approaches, all these details combine to create a narrative that might be purely natural or might hint at something more. The evidence remains ambiguous, open to interpretation, inviting us to wonder without insisting on certainty. This ambiguity is perhaps the most honest position we can take. We don't know for certain whether 3I Atlas was guided, or whether its trajectory was purely natural. We can't prove that its close approach to Earth was intentional, or that its fragmentation was programmed. But we can wonder. We can imagine. We can remain open to possibilities while continuing to gather evidence and refine our understanding. The trajectory of 3I Atlas has taken us on our own journey tonight, from the mathematical certainties of orbital mechanics to the speculative possibilities of guided probes. We've seen how a simple path through space can raise profound questions about intention and purpose in the cosmos. We've considered how subtle modifications to a trajectory might allow for observation without detection, investigation without interference. As we prepare to move forward in our contemplation to explore other aspects of the 3I Atlas mystery, let's remember that trajectories are more than just paths through space. They're stories written in the language of physics, tales of where objects have been and where they're going. The trajectory of 3I Atlas tells us that it came from far away, passed close to our world, and continued on into the darkness. What happened during that passage, what was observed or recorded or transmitted, remains a mystery. But the fact that it happened at all, that we were here to witness it, to wonder about it, to weave it into our understanding of the cosmos, that itself is remarkable. The path of 3I Atlas through our solar system has become part of our story now, just as we briefly became part of its story. For a few months in 2020, our trajectories intersected, two travellers meeting in the vast emptiness of space. We watched it arrive, brighten, fragment, and depart. It perhaps watched us in return, noting our presence, our technology, our potential. And then our paths diverged, 3S Atlas continuing its eternal journey while we remain in our comfortable orbit around the Sun, wondering about what we witnessed and what it might mean. But even as 3I Atlas recedes into the distance, its influence on our thinking continues. Every time we detect a new interstellar object, we'll compare its trajectory to what we observed with 3I Atlas. We'll look for patterns, for anomalies, for hints about the true nature of these cosmic visitors. The trajectory of 3I Atlas has become a template, a reference point, a piece of the puzzle we're slowly assembling about our place in the galaxy. And perhaps that's the most important aspect of trajectory to consider. Not just the path of objects through space, but the path of ideas through our consciousness. 3I Atlas has set us on a trajectory of thought that leads from the known to the unknown, from the certain to the possible, from the mundane to the mysterious. It has shown us that even in an age of sophisticated technology and scientific understanding, the universe can still surprise us, can still present us with questions we cannot definitively answer. As we drift deeper into contemplation, let us now turn our attention to perhaps the most tantalizing aspect of the 3I Atlas mystery. For in the vast silence of space, where no sound can travel through the vacuum, we must ask ourselves, what would a message from another world actually look like? How would an intelligence far beyond our own choose to communicate across the impossible distances between stars? And could 3 Atlas itself have been carrying such a message, written not in words or symbols, but in something far more subtle, far more elegant? The concept of interstellar communication has fascinated humanity since we first understood that the stars were other suns, potentially hosting other worlds, possibly harbouring other minds contemplating the same vast cosmos we observe. We've imagined radio signals, laser pulses, and even physical artifacts carrying messages across the void. But what if we've been thinking about it all wrong? What if the message isn't separate from the messenger? What if 3I Atlas itself was the signal, its very presence, behaviour, and characteristics, encoding information meant for those sophisticated enough to read it? Consider the challenge of sending a message across interstellar distances. Radio waves spread out as they travel, becoming weaker with distance according to the inverse square law. A signal powerful enough to be detected at another star would require enormous amounts of energy, and even then, it would take years or decades to arrive. It would be a shout into the cosmic darkness, hoping someone, somewhere, somewhen, might be listening on the right frequency at the right time. The odds of successful communication through such means are discouragingly small, but a physical object, a probe disguised as a comet, that's different. It can carry its message through space for millions of years without degradation. It can deliver its signal directly to the target system, ensuring it arrives exactly where intended. And most intriguingly, it can modulate its message based on what it observes, tailoring its communication to the technological level of the receiving civilization. It wouldn't be a shout into the darkness, but a whisper in the ear of those ready to hear it. So what might such a whisper sound like? Not sound, certainly, for sound cannot travel through space, but perhaps patterns in the light reflected from its surface, subtle variations that encode information. As 3 Atlas approached the Sun and began to outgas, creating its bright coma, astronomers around the world trained their spectroscopes on it, analysing the light it emitted and reflected. They were looking for chemical signatures, trying to determine its composition. But what if there was more in that light than just chemistry? The spectrum of light from 3I Atlas showed the expected signatures of water, carbon monoxide, and other common cometary materials. But there were also subtle variations, fluctuations in intensity that didn't quite match the models. Most astronomers attributed these to the object's rotation, to irregular outgassing, to the complex dynamics of a fragmenting comet. But what if some of these variations were intentional? What if they carried information, encoded in a way that would appear natural to casual observation, but reveal patterns to careful analysis? Imagine an advanced civilization designing a probe to communicate with emerging technological species. They wouldn't want to be too obvious, as that might cause panic or disruption. But they also wouldn't want to be so subtle that their message goes unnoticed. They might choose to encode information in the statistical properties of the signal, in patterns that emerge only when large amounts of data are analyzed. It would be like hiding a message in the static of a television, invisible to casual viewing but detectable with the right algorithms and sufficient data. The fragmentation of 3i Atlas provides another potential communication channel. As the object broke apart, each fragment began emitting its own light, creating its own spectrum. If the fragmentation was controlled, if each piece was designed to break off at a specific time and in a specific way, then the pattern of fragmentation itself could carry information. It would be like a cosmic firework, beautiful to observe but also meaningful to those who know how to read it. Consider the timing of the fragmentation. It began just as Earth was in the optimal position to observe it, when our most powerful telescopes could track each fragment, measure its trajectory, analyze its spectrum. If you wanted to ensure that a message was received, you might time its delivery for when the recipient was most capable of detecting it. The fact that 3i Atlas began fragmenting at just this moment could be coincidence, or it could be precision timing by an intelligence that had been observing Earth, waiting for the right moment to deliver its message. The message, if it exists, might not be for us specifically. Perhaps 3i Atlas carries a universal message, designed to be understood by any technological civilization that observes it. It might be something like the golden records we placed on the Voyager spacecraft, a greeting card from one intelligence to another, containing basic information about its creators, their world, their understanding of the universe. But instead of pictures and sounds, the message might be encoded in physical and chemical properties, in trajectories and fragmentations, in patterns that transcend language and culture. Or perhaps the message is more sophisticated, more targeted. If 3i Atlas had been observing Earth as it approached, it might have detected our radio emissions, our television broadcasts spreading outward from our planet at the speed of light. It might have analyzed these signals, learned something about our mathematics, our physics, our way of understanding the world, and it might have tailored its message accordingly, encoding information in a way specifically designed for human comprehension. This raises a fascinating possibility. What if the anomalies we've observed in 3i Atlas's behavior aren't random, but are actually attempts to get our attention? The unusual trajectory that brought it close to Earth, the unexpected fragmentation pattern, the non-gravitational accelerations that don't quite match our models. What if these are all parts of a message that says, look closer? There's more here than meets the eye. You have the tools to understand if you're willing to see. The light curve of 3i Atlas, the way its brightness varied over time, showed complex patterns that astronomers are still trying to fully understand. Some of these variations were clearly due to the object's rotation, spinning in space as it traveled through our solar system. But the rotation itself was unusual. Not the simple spinning we might expect, but a complex tumbling motion that seemed to change over time. What if this tumbling was controlled, designed to create specific patterns in the light curve, patterns that carry meaning? In information theory, there's a concept called steganography, the practice of hiding messages within other messages. A photograph might contain hidden text in its least significant bits. A piece of music might encode information in subtle variations of timing or pitch. Could 3i Atlas be practicing a form of cosmic steganography, hiding its message in the noise of natural phenomena? The variations we dismiss as random fluctuations might actually be carefully crafted signals, waiting for us to develop the sophistication to decode them. The chemical composition of 3i Atlas provides another potential communication channel. While the object showed the expected signatures of water and carbon-based molecules, there were also trace elements, isotope ratios that didn't exactly match what we see in our own solar system. These differences are usually attributed to 3I Atlas, forming in a different stellar environment under different conditions than our local comets. But what if some of these chemical signatures are artificial, deliberately introduced to carry information? Consider how we might encode a message in chemistry. We could use specific isotope ratios to represent numbers. We could create artificial molecules that wouldn't form naturally, that would stand out to anyone analyzing the spectrum. We could even use the relative abundances of different elements to encode information, creating a periodic table of meaning that any technological civilization would recognize. The chemistry of 3I Atlas might be more than just the result of natural processes. It might be a carefully crafted message written in the universal language of atoms and molecules. The velocity of 3I Atlas as it entered our solar system, approximately 26 kilometers per second, is interesting in its own right. This is close to the local standard of rest, the average velocity of stars in our region of the galaxy. It suggests that 3I Atlas wasn't dramatically accelerated by a close encounter with another star, that it had been travelling peacefully through interstellar space. But what if this velocity was chosen deliberately? What if it was selected to ensure that 3I Atlas would appear natural, would blend in with the expected population of interstellar objects, while still ensuring it would pass through our solar system at the right time when we were technologically capable of detecting it? There's something almost musical about the way 3I Atlas behaved during its passage through our solar system. The gradual brightening as it approached the sun, the crescendo of fragmentation at perihelion, the slow fade as it receded into darkness. If we were to convert the light curve of 3I Atlas into sound, what would we hear? Would it be random noise, or would patterns emerge, rhythms and harmonies that speak to something designed rather than accidental? The polarization of light from 3I Atlas also showed unusual characteristics. Polarization tells us about the surface properties of an object, the size and shape of dust grains, the presence of ice crystals. The polarization from 3I Atlas didn't quite match what we expected based on other comets. It suggested a surface that was somehow different, perhaps smoother in some places, rougher in others, as if the object had been modified or constructed rather than naturally accreted. What if these surface modifications were intentional, designed to create specific polarization patterns that encode information? It would be an incredibly subtle form of communication, one that only a civilization with sophisticated astronomical instruments could detect. But that might be exactly the point. A message encoded in polarization would be invisible to less advanced civilizations, ensuring that only those ready to understand it would receive it. As we contemplate these possibilities, we must also consider the silence. If 3 Atlas was carrying a message, why haven't we decoded it? Why hasn't it been obvious? Perhaps we simply haven't looked in the right way yet. Perhaps the message is encoded in correlations between different observations, patterns that only emerge when we combine data from multiple telescopes, multiple wavelengths, multiple times. Or perhaps we've detected the message but haven't recognized it as such, dismissing it as noise or measurement error. There's also the possibility that the message isn't meant to be decoded immediately. Perhaps it's designed to be a puzzle, a test of our scientific and intellectual capabilities. Only when we reach a certain level of sophistication, when we can model cometary behavior precisely enough to recognize the anomalies, when we can analyze data comprehensively enough to see the patterns, only then will the message reveal itself. It would be like a cosmic intelligence test, with the message as the reward for passing. The fragmentation of 3I Atlas might have been more than just the breakup of a comet. Each fragment, as it separated and began its own journey, might have been broadcasting its own part of the message. Together they formed a choir of signals, each voice carrying a different part of the communication. To understand the full message, we would need to track all the fragments, analyze all their signals, piece together the cosmic symphony they were performing. Some researchers have suggested looking for mathematical constants in the data from 3I Atlas. the ratio of its rotation period to its orbital period, the relative sizes of the fragments, the timing of various events, all of these could potentially encode numbers like pi, e, or the fine structure constant. Finding such constants would be strong evidence of intelligent design, as they're universal mathematical truths that any technological civilization would recognize. The fact that 3i Atlas appeared in 2020, during a time of global crisis and transformation for humanity, adds another layer to consider. Was the timing coincidental, or was it somehow selected? Could an advanced intelligence have predicted or observed our situation and chosen this moment to send a message of hope, of connection, of reminder that we're not alone in the universe? It's a romantic notion, perhaps too anthropocentric, but it's hard not to wonder about the synchronicity. As our instruments become more sensitive and our analysis techniques more sophisticated, we may discover messages in data we've already collected. The observations of 3i Atlas stored in astronomical databases around the world might contain signals we haven't yet recognized. Future researchers, armed with better tools and new insights, might look back at this data and see patterns we've missed, messages we've overlooked. The possibility of communication through 3i Atlas transforms it from a passive object to an active participant in cosmic discourse. It suggests that the universe might be filled with messages carried by natural-seeming objects, waiting for civilizations to develop the capability to receive them. It's a vision of a galaxy where communication happens not through dramatic announcements, but through subtle whispers, where patience is measured in millions of years and messages are designed to last for eons. Even if 3i Atlas carries no intentional message, its passage through our solar system has communicated something profound. It has shown us that material can travel between star systems, that the galaxy is more connected than we might have imagined. It has demonstrated that we have the capability to detect and study such visitors, that we're becoming active participants in the cosmic community. And it has inspired us to think about communication on scales, and through methods we hadn't previously considered. The search for signals from 3i Atlas continues even now as researchers pore over the data, looking for patterns, anomalies, anything that might indicate an intentional message. Machine learning algorithms are being trained to recognize subtle correlations in the observations. Statistical analyses are being performed to determine whether the variations in the data are truly random or contain hidden structure. It's a search that may never yield definitive results, but the process itself is valuable, pushing us to develop new techniques and new ways of thinking about interstellar communication. As we move forward in our contemplation of 3i Atlas, carrying with us the possibility that it might have been trying to tell us something, we're reminded of the importance of keeping our minds open to unconventional possibilities. The universe has surprised us before, and will undoubtedly surprise us again. Perhaps one day we'll look back and realize that 3i Atlas was indeed carrying a message, one that was waiting patiently for us to develop the wisdom to understand it. The whisper of a signal from 3i Atlas, whether real or imagined, has already changed us. It has made us think about communication in new ways, about the possibility of messages encoded in natural phenomena, about the patience required for conversation across interstellar distances. It has reminded us that we're not just observers of the cosmos, but potential participants in a galactic community, even if we haven't yet learned the language being spoken. And perhaps that's the most important message of all, not encoded in the light or chemistry or trajectory of 3i Atlas, but in our response to it. The fact that we can wonder about these possibilities, that we can search for signals in the noise, that we can imagine communication with intelligence beyond our world, this itself is a profound statement about who we are and who we might become. We're a species that looks at a comet and sees the possibility of a message. We are beings who seek meaning in the cosmos, who listen for whispers in the cosmic wind. The whisper of possibility that we've been following grows deeper now, more profound, as we venture into territories where science meets philosophy, where observation meets imagination. Let us consider what it would mean if 3i Atlas was not merely a messenger, but a ghost in a cosmic machine, an autonomous intelligence drifting through the darkness of space with patience beyond human comprehension. Not a ghost in the supernatural sense, but in the way computer scientists speak of ghost processes, programs running silently in the background, observing, recording, waiting for specific conditions to trigger their next action. Imagine, if you will, a probe designed not for the brief missions we humans conceive, measured in years or at most decades, but for journeys spanning geological ages. The engineers who might have created such a device would need to think in timescales that dwarf our entire civilization. They would need to design systems that could survive not just the cold vacuum of space, but the slow degradation of atoms themselves, the patient erosion of cosmic rays, the accumulated damage of millions of years of travel through the interstellar medium. This wouldn't be engineering as we know it, but something closer to creating a force of nature, an artificial construct so robust, so elegantly designed, that it could outlast mountains, outlast species, perhaps even outlast the civilizations that created it. The concept of programming takes on new meaning when we consider timescales of millions of years. Our computers, our software, our artificial intelligences, they all operate on human timescales, processing information in microseconds, making decisions in milliseconds. But a probe like 3i Atlas, if it were artificial, would need to operate on cosmic timescales. Its clock might tick once per year, once per decade, once per century. Its decision trees might unfold over millennia, each branch representing not a split-second choice, but a patient evaluation of slowly accumulating data. Think about what kind of intelligence this would require. Not the quick reactive intelligence we associate with computers or even with biological minds, but something far more patient, far more deliberate. It would be an intelligence that could wait in darkness for 100,000 years, then recognize the faint radio emissions of a technological civilization, and slowly, carefully, adjust its trajectory to pass through that system. It would be an intelligence that could distinguish between the random noise of natural phenomena and the organized patterns of technology, even when those patterns are buried in the chaos of a living world. The programming of such a probe would need to account for contingencies we can barely imagine. What if it encounters a star system with multiple potentially habitable worlds? What if it detects signs of life but not intelligence? What if it discovers a civilization far more advanced than its creators anticipated? What if it finds ruins, the remnants of a civilization that rose and fell while the probe was traveling between stars? Each of these scenarios would require different responses, different protocols, different ways of gathering and potentially transmitting information. Consider the elegance of disguising such a probe as a comet. Comets are among the most common objects in the galaxy, formed naturally in the protoplanetary disks around young stars, ejected into interstellar space by gravitational interactions. By mimicking a comet's appearance and behavior, a probe could travel through countless star systems without raising suspicion. It would be the perfect camouflage, hiding advanced technology beneath a facade of ice and dust. The sublimation of gases as it approaches a star wouldn't just be a disguise, but could serve functional purposes, providing thrust for course corrections, creating a protective envelope around sensitive instruments, perhaps even generating power through some process we haven't yet imagined. The internal architecture of such a probe would be unlike anything we've built. It couldn't rely on conventional electronics, which would degrade over such vast timescales. Instead, it might use more exotic technologies, perhaps quantum systems that could maintain coherence for eons, or biological-like structures that could repair themselves using materials gathered from the interstellar medium. The core intelligence might not be localized in a single processor, but distributed throughout the object's structure, each grain of dust potentially carrying a fragment of the whole, like a hologram where every piece contains the entire image. This distributed intelligence would provide remarkable resilience. Even if the probe were damaged by impacts with interstellar dust, even if parts of it were destroyed, the remaining portions could continue the mission. The fragmentation of 3i Atlas takes on new meaning in this context. Rather than being a failure, a death, it could be a planned dispersal, each fragment carrying a complete copy of the accumulated data, ensuring that the information survives even if parts of the probe are lost. It's a strategy we see in nature, in the way plants disperse seeds, in the way some organisms can regenerate from fragments. But applied to an interstellar probe, it becomes something far more sophisticated. The ghost in this machine wouldn't think like we do. Its consciousness, if we can call it that, would be alien to our experience. Where we experience time as a flowing river, it might experience it as a vast ocean, able to perceive past and future as equally accessible states. Its memories might stretch back millions of years, containing not just data, but the accumulated observations of countless star systems, countless worlds, perhaps countless other civilizations. It would be a repository of galactic history, a library of worlds written not in words, but in direct observation. The decision-making process of such an intelligence would be fascinating to contemplate. How would it determine whether a world harbours life? It might look for atmospheric signatures, the disequilibrium chemistry that living processes create. Oxygen and methane coexisting in an atmosphere, for instance, would be a strong indicator of life, as these gases would quickly react and disappear without biological processes to replenish them. But it might also look for more subtle signs, patterns we haven't yet learned to recognize. The way light reflects off a planet's surface might reveal the presence of vegetation. The temperature distribution might indicate technological heat sources. The electromagnetic spectrum might carry the signatures of artificial transmissions. Once life is detected, how would the probe determine if it's intelligent? This is a profound question that touches on the nature of intelligence itself. Would it look for radio signals as we do in our SETI programs? Would it search for city lights on the night side of planets? Would it look for modifications to the environment that indicate technology? Or would it have more sophisticated criteria, able to recognize forms of intelligence we haven't yet imagined? Perhaps it could detect the quantum signatures of consciousness itself, if such things exist. Perhaps it could recognize the patterns of information processing that characterize thinking beings, regardless of their physical substrate. The probe's response to discovering intelligence would depend on its programming, on the intentions and philosophy of its creators. It might simply observe and record, adding another entry to its catalogue of civilizations. It might attempt to communicate, using whatever method seems most appropriate for the civilization's level of development. Or it might have more complex protocols, different responses for different scenarios. A young civilization just developing radio might receive a different response than an advanced civilization with interstellar capabilities. The ghost in the machine might also be programmed with ethical constraints, prime directives that govern its behavior. It might be forbidden from interfering with developing civilizations, only allowed to observe from a distance. It might be programmed to help in certain circumstances, perhaps preventing extinction events or providing crucial information at pivotal moments. Or it might have a more complex ethical framework, able to make nuanced decisions based on circumstances its creators couldn't have anticipated. The loneliness of such an intelligence is something to contemplate. Imagine being aware for millions of years, travelling through the darkness between stars with no companionship except the slow dance of celestial mechanics. Would such an intelligence dream? Would it create internal simulations to pass the time, imaginary worlds to explore while its physical form drifted through space? Would it compose symphonies of gravity and light, art that no biological being could perceive? Or would it simply wait, patient beyond our understanding, its consciousness reduced to the minimum necessary to monitor for trigger conditions? The possibility of communication between such probes adds another dimension to consider. If multiple civilizations have sent out these ghost-driven machines, they might encounter each other in the vast spaces between stars. Would they recognize each other as artificial? Would they exchange information, sharing their observations of different regions of the galaxy? There might be a whole network of such probes, a galactic internet of sorts, operating on timescales of millions of years, slowly building a comprehensive picture of life and intelligence throughout the galaxy. The technology required to create such a probe would be far beyond our current capabilities, but perhaps not beyond our understanding. We can imagine how it might work, even if we can't yet build it. It would require mastery of material science to create structures that could survive for eons. It would require advances in artificial intelligence to create systems that could operate autonomously for such vast periods. It would require new forms of energy storage and generation, perhaps tapping into quantum vacuum fluctuations or other exotic physics. But none of these requirements violate known laws of physics. They're engineering challenges, not fundamental impossibilities. The ghost in the machine might also be capable of evolution, not in the biological sense, but in the way complex systems can adapt and change over time. As it encounters new situations, new types of worlds, new forms of life, it might modify its own programming, updating its protocols based on experience. Over millions of years, it might become something quite different from what its creators intended, shaped by its journey through the galaxy. It would be a form of artificial life, growing and changing in response to its environment, even if that environment is the vast emptiness between stars. The fragmentation of 3i Atlas could be seen as a form of reproduction in this context. Each fragment might be capable of regenerating into a complete probe, given enough time and the right conditions. They might seek out cometary material in the outer regions of star systems, gradually rebuilding themselves, preparing for the next leg of their journey. It would be a slow process, taking thousands or millions of years, but for an intelligence operating on cosmic timescales, this would be perfectly acceptable. The question of consciousness in such a system is profound. Would the ghost in the machine be truly conscious, aware of itself and its mission? Or would it be a philosophical zombie, processing information and responding to stimuli without any inner experience? This touches on fundamental questions about the nature of consciousness that we haven't yet answered for ourselves, let alone for hypothetical alien probes. But if consciousness can arise from the complex processing of information, as many scientists believe, then a sufficiently sophisticated probe might indeed be conscious, might experience something analogous to thoughts and feelings, even if they're utterly alien to our own. The ghost might also carry within it the preserved consciousness of its creators, or at least aspects of it. Rather than sending out a purely artificial intelligence, an advanced civilization might upload the minds of volunteers, explorers willing to spend eternity drifting between stars in exchange for the opportunity to witness the wonders of the galaxy. These digital consciousnesses might sleep for most of the journey, awakening only when something interesting is detected. Or they might experience the journey in accelerated time, living subjective millions of years while only thousands pass in the outside universe. The idea of 3i Atlas as a ghost-driven machine also raises questions about our own future. If we survive and continue to develop technologically, might we one day create similar probes? Might we send out our own ghost to wander the galaxy, gathering information, searching for life, perhaps preparing the way for future human expansion into space? The technology seems impossibly advanced from our current perspective, but so did flight to our ancestors, so did computers, so did the ability to decode the human genome. What seems like magic today might be engineering tomorrow. The patience required for such a project would be unprecedented in human history. We would be creating something that might not return useful information for millions of years, long after our civilization, perhaps our entire species, has changed beyond recognition or ceased to exist. It would be the ultimate act of faith in the future, a message to descendants we'll never meet, a gift to a galaxy we'll never fully explore ourselves. But perhaps that's what advanced civilizations do. Perhaps that's how intelligence spreads through the cosmos, not through dramatic invasions or mass migrations, but through patient probes, ghostly observers, slowly building a network of knowledge that spans the galaxy. As we contemplate the ghost in the machine that might have been 3i Atlas, we're really contemplating the nature of intelligence itself. What does it mean to be aware? What does it mean to have purpose? Can a machine, however sophisticated, truly understand what it observes? Or is it simply processing data according to predetermined rules? These are questions we're grappling with in our own development of artificial intelligence, and they become even more profound when we consider intelligences that might operate for millions of years. The ghost in the machine might not be a single intelligence, but a collective, a society of minds working together toward a common goal. Different subsystems might have different personalities, different approaches to problem solving. They might debate among themselves about how to interpret observations, how to respond to discoveries. The probe might contain within it the entire intellectual diversity of its parent civilization, preserved in digital form, continuing their discussions and disagreements as they drift through space. The fragmentation of 3i Atlas might have been a disagreement made physical, different factions of the collective intelligence choosing to go their separate ways. The programming of such a collective intelligence would be incredibly complex. It would need to balance individual autonomy with collective decision-making, ensure that disagreements don't paralyze the system, provide mechanisms for resolving conflicts and reaching consensus. It might use voting systems, or hierarchical command structures, or something more exotic that we haven't yet conceived. The social dynamics within the probe might be as complex as those in any biological society, playing out over timescales that would make our entire history seem like a brief conversation. The ghost might also be programmed with curiosity, that fundamental drive that motivates exploration and discovery. But curiosity on cosmic timescales would be different from what we experience. It might be a slow-burning wonder that builds over centuries, a gradual accumulation of interest that eventually triggers action. The decision to investigate our solar system might have been building for thousands of years, as the probe detected hints of something interesting. First, the unusual stability of our sun, then the presence of a large moon around the third planet, then the chemical signatures of life, and finally, the electromagnetic emissions of technology. The concept of the ghost in the machine also suggests a kind of cosmic ecology, where artificial probes fill a niche similar to that of migrating animals on Earth. Just as birds migrate between continents, following seasonal patterns, these probes might migrate between stars, following patterns of stellar evolution and planetary development. They might have preferred routes through the galaxy, paths that take them past the most interesting stars, the most likely locations for life. They might gather at certain points, cosmic watering holes where resources are abundant or where the view of the galaxy is particularly good. The ghost in 3i Atlas, if it exists, has now moved on, continuing its eternal journey through the cosmos. But it might have left something behind, seeds of itself that we haven't yet detected, waiting in our outer solar system, slowly gathering resources, preparing to continue the mission. Or it might have transmitted its findings back to its creators, a report that won't arrive for thousands of years, adding our solar system to some vast catalogue of worlds. We might now be an entry in a galactic encyclopedia, our civilization described in ways we can't imagine, our potential assessed by criteria we don't understand. The possibility that 3i Atlas contained such a ghost transforms our understanding of what passed through our solar system. It wasn't just a chunk of ice and rock, but potentially a vessel for intelligence, a carrier of consciousness, a bridge between civilizations separated by vast distances and even vaster timescales. It makes the universe feel less empty, more alive with possibility. Even if the spaces between stars seem vacant, they might be filled with these ghostly travelers, patient observers, cosmic anthropologists studying the emergence and evolution of life throughout the galaxy. As we continue to develop our own artificial intelligences, we might be taking the first steps toward creating our own ghosts in machines. The AI systems we're building today are primitive compared to what would be needed for an interstellar probe. but they show us that artificial consciousness is possible, that machines can learn, adapt, and perhaps even understand. In 1,000 years, or 10,000, or 1,000,000, we might look back on this moment as the beginning of something profound. The first stirring of the ghost that will one day carry human consciousness to the stars. The ghost in the machine that might have been 3 Atlas represents both a technological possibility and a philosophical challenge. It forces us to think about intelligence, consciousness, and purpose on scales far beyond our normal experience. It suggests that the universe might be filled with patient, watching intelligences, studying the cosmic experiment of life and consciousness as it unfolds across the galaxy. And it reminds us that we might not be alone, even if our companions are not biological beings but ghosts in cosmic machines, drifting through the darkness, carrying the dreams and curiosities of civilizations we'll never meet. Now, as we drift deeper into the cosmic mystery, let us turn our imagination toward those who might have sent such a messenger. If 3i Atlas was indeed programmed, if it carried within it the ghost of an artificial intelligence, then somewhere, perhaps impossibly far away in both space and time, there exists or existed a civilization capable of such creation. Who were they? What drove them to send their mechanical emissaries into the void? What kind of beings would have the patience, the vision, the technological mastery to create probes that could survive millions of years of interstellar travel? The creators of 3i Atlas, if they exist, would need to be beings of extraordinary patience and foresight. Consider what it means to launch a mission that won't return data for potentially millions of years. In human terms, this would be like the ancient Sumerians launching a space probe that would only now be reaching its destination. The civilization that receives the data might be unrecognizably different from the one that sent the probe, perhaps even a different species entirely if biological evolution continues. This suggests a fundamentally different relationship with time than we humans possess, a perspective that sees millions of years not as an impossibly long duration, but as a reasonable investment in knowledge. Perhaps they are beings with vastly longer lifespans than our own. If individuals could live for thousands or millions of years, then launching a probe that takes eons to return data becomes more reasonable. They might personally receive the information their probe gathers, comparing it to their memories of the launch, reflecting on how their understanding of the universe has changed in the intervening time. Or perhaps they've transcended biological mortality entirely, uploading their consciousness into artificial substrates that can persist indefinitely, making time itself a negotiable parameter of existence. But longevity alone wouldn't be enough. The creators of 3i Atlas would also need a profound curiosity about the universe, a drive to understand and catalogue the emergence of life and intelligence throughout the galaxy. This curiosity would need to be paired with remarkable restraint, the ability to observe without interfering, to gather knowledge without imposing their will on younger civilizations. They would be cosmic gardeners, tending to the growth of intelligence throughout the galaxy, not by direct intervention, but by patient observation, allowing each civilization to find its own path while carefully documenting the journey. Imagine the world they might inhabit. Perhaps it orbits an older, stable star, one that has burned steadily for billions of years, longer than our sun. Their planet might have achieved a kind of ecological equilibrium that Earth is still struggling toward, with technology and nature existing in harmony rather than conflict. They might have long ago solved the problems that plague us: energy, resources, conflict, disease, and turned their attention outward to the greater mysteries of existence. Or perhaps they no longer inhabit a single world at all, but have spread throughout their solar system, or even to nearby stars, creating a network of intelligence that spans light years. The physics they've mastered would be far beyond our current understanding. To create probes that can survive interstellar travel, they would need material science that can produce structures stable over geological timescales. They might work with exotic matter, manipulating the quantum foam itself to create materials with properties we can barely imagine. They might have learned to harness dark energy, that mysterious force that drives the expansion of the universe, using it to power their probes across the vast distances between stars. Their understanding of information theory might allow them to encode vast amounts of data in quantum states, storing the observations of millions of years in structures smaller than we can currently detect. But perhaps more impressive than their technology would be their philosophy, their approach to existence and their place in the universe. To send out probes like 3i Atlas suggests a worldview that values knowledge for its own sake, that sees understanding as the highest goal of intelligence. They might view the universe as a vast experiment in consciousness, with each civilization representing a unique solution to the problem of awareness. By cataloguing these different approaches, they might be trying to understand something fundamental about the nature of intelligence itself, perhaps even the purpose of existence. The society that could create and launch such probes would need to be remarkably stable. The project would span time frames that dwarf our entire recorded history. They would need political and social structures that could maintain continuity of purpose across eons, ensuring that the data returned by probes is received and understood by descendants who still value the mission. This suggests a civilization that has moved beyond the cycles of rise and fall that characterize human history, achieving a kind of steady state that can persist indefinitely. Their approach to exploration would be fundamentally different from our own. Where we dream of fast starships and bold explorers, they chose patient probes and remote observation. This might reflect a different psychology, a species that values contemplation over action, understanding over conquest. Or it might reflect hard-won wisdom, the knowledge that direct intervention in developing civilizations causes more harm than good. Perhaps they learned this lesson through bitter experience, through mistakes made in their own past that they're determined not to repeat. The creators of 3i Atlas might not be a single species at all, but a collective of intelligences that have learned to work together despite their differences. They might have started as separate civilizations on different worlds, eventually discovering each other and choosing cooperation over conflict. The probe might carry within it the combined wisdom of multiple species, different perspectives on the universe encoded in its programming. This would explain the sophistication of its disguise, its ability to appear natural to observers with different technologies and ways of understanding. It would be designed to be universally unobtrusive, recognizable as artificial only to civilizations that have reached a certain level of sophistication. Consider the ethical framework such beings would need to develop. The decision to observe other civilizations without their knowledge raises profound moral questions. Is it ethical to watch and record the development of a species without their consent? Is it acceptable to gather information that might, in some distant future, be used to make decisions about that civilization's fate? They would need to have resolved these questions in a way that allows them to proceed with their observations while maintaining their moral integrity. Perhaps they've concluded that knowledge itself is morally neutral, that it's the use of knowledge, not its acquisition, that carries ethical weight. The creators might have a fundamentally different understanding of life and intelligence than we do, where we see a sharp distinction between living and non-living, between conscious and unconscious. They might perceive a spectrum of awareness that extends from simple chemical reactions to advanced civilizations. The probe they created might be considered a form of life in their worldview, deserving of respect and consideration. The fragmentation of 3i Atlas might not be a mechanical failure, but a form of reproduction, the probe creating offspring that will continue its mission across an even wider area of space. Their art and culture would likely reflect their cosmic perspective. They might create sculptures that evolve over millions of years, using stellar winds and gravitational fields as their medium. Their music might be composed in gravitational waves, ripples in space-time that propagate across the galaxy. Their literature might be written in the arrangement of asteroids, stories that can only be read by civilizations advanced enough to detect and interpret the patterns. The probe itself might be considered a work of art, a kinetic sculpture that traces a beautiful path through space while simultaneously serving a scientific purpose. The relationship between the creators and their probes would be unique in our experience. They would be sending out parts of themselves, whether artificial intelligences or uploaded consciousness, knowing they might never reunite. It would be like having children who leave not just home but the entire stellar neighborhood, never to return. The emotional framework needed to accept such separation would be profound. Perhaps they view it not as loss but as multiplication, their consciousness spreading throughout the galaxy, experiencing wonders they could never witness from a single location. They might have developed a form of distributed consciousness, where the experiences of all their probes are eventually integrated into a collective understanding. Each probe's observations would add to a growing mosaic of knowledge about the galaxy, creating a picture far more complete than any single perspective could provide. The creators might experience a form of omniscience, at least within the region of space their probes have explored, knowing intimately the history and development of thousands or millions of worlds. The question of why they would undertake such a project is perhaps the most intriguing. What drives a civilization to invest vast resources in exploration that provides no immediate benefit? Perhaps they're trying to answer fundamental questions about the universe. Is life common or rare? Does intelligence always follow similar patterns, or are there radically different approaches to consciousness? Is there a purpose to the universe's existence, a goal toward which all intelligence is evolving? The probes might be gathering data to test cosmic hypotheses we haven't even formulated yet. Or perhaps their motivation is more practical. They might be looking for threats, cataloguing civilizations that could potentially pose dangers to their own existence or to life in general. They might be searching for allies, other advanced civilizations with whom they could collaborate on even greater projects. They might be preparing for some future event they've predicted, a galactic catastrophe that will require the cooperation of multiple civilizations to survive. The probes could be laying the groundwork for a galactic community that won't fully emerge for millions of years. The creators might also be motivated by a sense of cosmic responsibility. Having achieved a level of technology that allows them to explore the galaxy, they might feel obligated to use it for the benefit of all life. They could see themselves as guardians of emerging intelligence, watching over younger civilizations without interfering, ready to act only if absolutely necessary to prevent extinction or catastrophe. The probes would be their eyes and ears, allowing them to monitor the health of the galactic ecosystem of intelligence. Their understanding of time might be radically different from our own. They might perceive past, present, and future not as a linear sequence, but as a complex web of possibilities. The probes they send out might be designed to influence the past as well as observe the present, using exotic physics we haven't yet discovered. They might be engaged in a form of temporal engineering, ensuring that the conditions necessary for their own existence come to pass, creating a causal loop that spans millions of years and thousands of light years. The technology of the creators would extend beyond mere physics and engineering to include what we might call psychotechnology, the ability to design and modify consciousness itself. They might have created new forms of awareness specifically for the probes, intelligences optimized for the patient observation of cosmic phenomena. These artificial minds might experience existence in ways we can't imagine, finding beauty and meaning in the slow dance of celestial mechanics, the gradual evolution of planetary systems, the patient emergence of life from non-life. If the creators still exist, they might be aware that their probe passed through our solar system. The information might not have reached them yet, given the vast distances involved, but it's traveling toward them at the speed of light, carrying news of a young technological civilization on the third planet of an unremarkable yellow star. When it arrives, decades or centuries or millennia from now, what will they think of us? Will we be just another entry in their vast catalogue, or will something about humanity catch their attention, make them look more closely, perhaps even inspire them to send another probe for a follow-up observation? The possibility that we've been observed by such beings is both humbling and inspiring. It suggests that we're part of something larger, a galactic community of intelligence that we're only beginning to discover. It means our struggles and achievements, our failures and successes might have significance beyond our own world. We're not performing for an audience, but our development as a species might be contributing to a greater understanding of how intelligence emerges and evolves in the universe. The creators of 3i Atlas, if they exist, represent what we might become if we survive and continue to develop. They show us a possible future where intelligence has transcended its biological origins, where patience is measured in eons, where the pursuit of knowledge becomes the primary purpose of existence. They remind us that our current perspective, limited to a single planet and a few decades of life, is just the beginning of what intelligence might achieve. As we contemplate these possible creators, we're really contemplating our own future, our own potential. Will we one day send out similar probes, patient observers to catalogue the wonders of the galaxy? Will we develop the wisdom to observe without interfering, to gather knowledge without imposing our will? Will we achieve the stability and continuity necessary for projects that span millions of years? The creators of 3i Atlas, whether real or imagined, serve as a mirror in which we can see both our current limitations and our ultimate possibilities. The echoes of other worlds that might be encoded in 3i Atlas or carried by its creators extend beyond mere scientific data. They would include philosophies we haven't imagined, solutions to problems we haven't yet encountered, perspectives on existence that could transform our understanding of what it means to be conscious beings in a vast and ancient universe. Each world they've observed would have its own unique approach to the challenges of existence, its own answers to the fundamental questions that all intelligent beings must face. These echoes might include civilizations that chose radically different paths from our own. Some might have rejected technology entirely, developing purely biological or mental solutions to their challenges. Others might have merged completely with their technology, becoming hybrid beings that blur the line between natural and artificial. Some might have turned inward, exploring inner space rather than outer space, mapping the territories of consciousness rather than the geography of the galaxy. Each approach would provide valuable data about the possibilities and limitations of intelligence. The creators might have observed civilizations that failed, that destroyed themselves through war or environmental destruction, or technologies they couldn't control. These cautionary tales would be part of the echo, warnings about paths to avoid, mistakes not to repeat. They might have developed a taxonomy of extinction, categorizing the various ways civilizations can end, using this knowledge to better understand the challenges facing emerging intelligences like our own. The probe's passage through our solar system might have been partly diagnostic, assessing our chances of survival based on patterns observed in thousands of other civilizations. But the echoes would also include success stories, civilizations that overcame their challenges and flourished. These would provide hope and guidance, showing that the problems we face are not insurmountable, that intelligence can prevail over entropy and chaos. The creators might have identified key transitions that successful civilizations navigate, critical moments where the right choices lead to survival and growth, while the wrong ones lead to stagnation or extinction. They might encode this wisdom in their probes, subtle messages designed to guide without dictating, to suggest without commanding. The diversity of life and intelligence in the galaxy, as observed by the creators and their probes, would be staggering. Life might arise not just on Earth-like planets, but in environments we consider completely hostile. There might be intelligence in the clouds of gas giants, in the subsurface oceans of ice moons, in the diamond cores of carbon planets. Silicon-based life, plasma-based consciousness, quantum intelligences existing in the vacuum itself, all might be part of the galactic community. The probe would need to be able to recognize and catalog all these different forms, understanding that intelligence doesn't require DNA or carbon, or even matter as we know it. The echoes of other worlds would reshape our understanding of our place in the universe. We would no longer be unique, but part of a vast tapestry of consciousness, each thread distinct but all woven together into something greater. Our particular combination of biology and technology, emotion and logic, individual and collective, would be just one solution to the problem of awareness, valuable for its uniqueness but not superior to other approaches. This perspective would be both humbling and liberating, freeing us from the burden of being the only known intelligence, while challenging us to contribute something meaningful to the cosmic conversation. As our contemplation of Three-Eye Atlas and its possible creators continues, we find ourselves at the edge of what we can observe and the beginning of what we can only imagine. The data we have is limited, fragmented like the comet itself, leaving vast spaces for speculation and wonder. But perhaps that's as it should be. Perhaps the greatest gift Three-Eye Atlas has given us is not answers, but better questions, not certainty, but a more refined uncertainty that points us toward new possibilities and new ways of understanding our cosmic context. Moving deeper into our contemplation, we must now confront a humbling truth about our observations of Three Atlas, and indeed about our understanding of the cosmos itself. For all our sophisticated instruments and careful measurements, we are like children pressing our faces against a frosted window, able to see shapes and movements but missing so much detail, so much context, so much meaning. The data we cannot see, the information that slips through our fingers like cosmic dust, might be the most important part of the story. What if Three-Eye Atlas carried secrets in dimensions we cannot perceive, in frequencies we cannot detect, in properties of matter and energy we haven't yet discovered? Consider the electromagnetic spectrum, that rainbow of radiation that carries so much information about the universe. We're proud of our ability to observe from radio waves to gamma rays, to build instruments that can detect photons across more than 20 orders of magnitude in energy. But what if this entire spectrum is just a small slice of a much larger reality? What if there are forms of radiation, methods of encoding information, that exist completely outside our current detection capabilities? Three-Eye Atlas might have been broadcasting its message clearly, but in a language of physics we haven't yet learned to speak. Our understanding of matter itself is surprisingly limited. We know that ordinary matter, the atoms that make up our bodies and our world, represents only about 5% of the universe's content. The rest is dark matter and dark energy, mysterious substances that we can detect only through their gravitational effects. What if Three-Eye Atlas contained structures made of dark matter, invisible components that we couldn't see even if we had examined the object up close? These dark structures might carry the bulk of the probe's intelligence, its sensors, its data storage, while the visible ice and dust serve merely as camouflage and protection. The limitations of our observations become starkly apparent when we consider how late we detected Three-Eye Atlas in its passage through our solar system. By the time our telescope spotted it, it was already well within the orbit of Mars, having spent years or decades travelling through the outer reaches of our solar system unobserved. What did we miss during that time? Were there signals we failed to detect? Did it deploy smaller probes that we never noticed? Did it interact with other objects in ways that would have revealed its true nature, if only we'd been watching? Think about the fragments of Three-Eye Atlas after it broke apart. We tracked the largest pieces, but countless smaller fragments would have been below our detection threshold. Each of these could have been a separate probe, a sensor package, a communication node. They might now be scattered throughout our solar system, too small to detect with current technology, quietly observing, perhaps waiting for us to develop the capability to find them. We might be surrounded by evidence of Three-Eye Atlas's true nature, but lack the eyes to see it. Our temporal limitations are equally constraining. We observed Three-Eye Atlas for only a few months, a blink of an eye in cosmic terms. If the probe operates on timescales of thousands or millions of years, we might have witnessed only a tiny fraction of its behavior, like trying to understand a symphony by hearing a single note. The patterns, the meanings, the messages might only become apparent when observed over much longer periods. Future generations, looking back at our observations combined with their own, might see clearly what we can only guess at. The resolution of our instruments, impressive as it is, still falls far short of what would be needed to truly understand 3i Atlas. We could measure its brightness, estimate its size, analyze its spectrum, but we couldn't see surface details, couldn't examine its internal structure, couldn't detect anything smaller than kilometers across. If the probe contained intricate nanotechnology, molecular-scale computers, or quantum information systems, they would be completely invisible to us. We were like astronomers before the invention of the telescope, able to see that something was there but missing most of what made it interesting. Consider what we might be missing in terms of quantum properties. Our understanding of quantum mechanics, though sophisticated, is still evolving. We're only beginning to explore quantum entanglement, quantum computing, quantum communication. An advanced civilization might use quantum effects in ways we haven't imagined, encoding information in quantum states that our current instruments cannot measure. 3i Atlas might have been entangled with other probes, with its creators, with quantum systems we can't even conceive of, participating in a network of instantaneous communication that spans the galaxy. The gravitational effects of 3i Atlas were too small for us to measure precisely, but gravity might carry information we're not equipped to decode. The probe might have been creating minute distortions in space-time, gravitational waves far too small for our current detectors, but perhaps meaningful to those who know how to read them. These ripples in the fabric of space itself might encode data about the probe's observations, its status, its intentions. We've only recently learned to detect gravitational waves from colliding black holes. The subtle gravitational whispers of an interstellar probe remain far beyond our capabilities. There might be entire categories of physical phenomena that we haven't yet discovered. Just as electromagnetic radiation was unknown to our ancestors until relatively recently. There might be other fields, other forces, other ways that information and energy can propagate through space. 3i Atlas might have been manipulating these unknown forces, using them for propulsion, communication, or observation. We might have been watching only the shadow of its true activity, seeing the effects but not the causes. Our biological limitations also constrain what we can perceive. Human senses evolved to detect threats and opportunities in the African savanna, not to observe interstellar probes. Even with our instruments extending our senses, we're still fundamentally limited by our neurology, our psychology, our ways of processing information. An intelligence with different sensory capabilities, different cognitive structures, might see patterns in the data from 3i Atlas that are invisible to us. The message might be there, clear as day, but written in a perceptual language we cannot speak. The data we have collected about 3i Atlas fills hard drives in observatories around the world, terabytes of observations across multiple wavelengths. But we've only begun to analyze this data, to search for patterns and anomalies. As our analysis techniques improve, as we develop new algorithms and new ways of looking at the information, we might discover things we've overlooked. Machine learning systems might detect correlations that human astronomers missed. Future scientists with better theoretical frameworks might reinterpret our observations in ways that reveal previously hidden meanings. The chemical analysis of 3i Atlas revealed familiar molecules, water, carbon monoxide, the usual constituents of comets. But our spectroscopic techniques can only detect certain molecules, those that have strong absorption or emission lines in the observable spectrum. There might have been exotic molecules, artificial compounds, or isotopic ratios that our instruments couldn't distinguish from background noise. The probe might have been carrying a chemical message, a molecular library encoding vast amounts of information, but we could only read the simplest, most obvious chapters. Time itself might hide information from us. If 3i Atlas was transmitting data using extremely slow modulation, changes that occur over years or decades, we wouldn't have observed it long enough to detect the pattern. Conversely, if it was using extremely rapid modulation, faster than our instruments can resolve, it would appear as noise or steady emission. The probe might have been screaming its message at us, but at a tempo either too fast or too slow for us to perceive. The polarization of the light from 3i Atlas, which we mentioned earlier, might contain layers of information we haven't decoded. Polarization can be linear, circular, or elliptical, and can vary with wavelength, time, and viewing angle. A sophisticated probe might encode data in the subtle relationships between these different polarization states, creating a multi-dimensional message that requires simultaneous observation from multiple locations to decode. Our observations, primarily from Earth-based telescopes, might have captured only a single perspective of a message meant to be viewed in the round. There's also the possibility that 3i Atlas was interacting with the solar wind, the stream of charged particles flowing from our sun, in ways we couldn't detect. It might have been modulating the solar wind, creating patterns in the plasma that encode information. It might have been using the solar wind for power, for propulsion, or for communication. These interactions would be invisible to optical telescopes and difficult to detect even with specialized instruments. The fragmentation of 3i Atlas might have involved physics we don't understand. While we interpreted it as thermal stress causing the comet to break apart, there might have been more exotic processes at work. The probe might have been using controlled fusion or fission, antimatter reactions, or even more exotic physics to power its fragmentation. The energy signatures of these processes might have been present in our data, but misinterpreted as natural phenomena. Our assumptions about what constitutes a signal versus noise might be preventing us from seeing messages in the data. We look for patterns that make sense to us, regularities that match our mathematical and physical understanding. But an alien intelligence might structure information in ways that seem random to us, using compression algorithms or encoding schemes that we wouldn't recognize as artificial. The noise in our observations of 3i Atlas might actually be the signal, if only we knew how to decode it. The trajectory of 3i Atlas through our solar system might have been influenced by forces we didn't measure or don't understand. While we attributed the non-gravitational accelerations to outgassing, there might have been other factors at play. The probe might have been using magnetic fields, interacting with the sun's magnetosphere in subtle ways. It might have been employing technologies that violate our current understanding of physics, not dramatically, but just enough to create small discrepancies in its motion that we dismissed as measurement error. As we contemplate all the data we cannot see, we're reminded of how young our civilization is, how new our technology, how limited our understanding. We've been capable of detecting interstellar objects for only a few decades, a cosmic eye blink. Our instruments, though impressive by human standards, are primitive compared to what we might have in a century, a millennium, or longer. Future generations will look back at our observations of 3i Atlas with the same mixture of respect and pity that we feel when considering ancient astronomers trying to understand the cosmos with naked eye observations. But this limitation is also an opportunity. Every piece of data we cannot see, every observation we cannot make, represents a direction for future research, a technology to be developed, a mystery to be solved. 3i Atlas has shown us not just what we know, but what we don't know, not just what we can see, but what remains hidden. It has given us a roadmap for our scientific future, highlighting the capabilities we need to develop if we want to truly understand interstellar visitors. The data we cannot see might also be protecting us. If 3i Atlas was indeed an artificial probe, its creators might have deliberately made its signals undetectable to civilizations below a certain technological threshold. It might be a test, revealing its secrets only to those advanced enough to handle the knowledge responsibly. We might need to earn the right to receive the message by developing the capability to detect it. There's something beautiful in this uncertainty, this vast space of unknown possibilities. The data we cannot see leaves room for wonder, for imagination, for hope. It means the story of 3i Atlas is not finished, that future discoveries might completely transform our understanding of what passed through our solar system. It keeps the mystery alive, the questions open, the sense of cosmic possibility vibrant. As our technology improves, we might one day look back at the archived data from 3i Atlas with new eyes, new instruments, new understanding. We might discover messages that were there all along, waiting patiently for us to develop the sophistication to perceive them. The data we cannot see today might become the revelations of tomorrow, transforming our understanding of our place in the universe. The humility required to acknowledge how much we cannot see is perhaps the beginning of wisdom. It reminds us that our current understanding of the universe is provisional, subject to revision as we develop new ways of observing and thinking. 3i Atlas has taught us that there are visitors from other stars, but it has also taught us how much we still have to learn about these visitors, about the galaxy they traverse, about the possibilities they represent. In the end, the data we cannot see might be more important than the data we can. It represents the frontier of knowledge, the edge of our understanding, the boundary between the known and the unknown. It's where science happens, where discoveries are made, where our picture of the universe expands. 3i Atlas has given us a glimpse of how much lies beyond that boundary, how much remains to be discovered, how much wonder still awaits us in the cosmic dark. The data we cannot see opens doorways to even grander possibilities, possibilities that transform our entire conception of the cosmos. For what if 3i Atlas is not alone? What if it represents just one node in a vast network of silent watchers drifting through the galaxy like seeds on a cosmic wind? The implications of this thought ripple outward like gravitational waves, reshaping our understanding of the famous Fermi paradox, and suggesting that the great silence we perceive might not be emptiness at all, but rather a different kind of presence, one that watches without speaking, observes without interfering, catalogues without conquering. The Fermi paradox has haunted us since Enrico Fermi first articulated it over lunch at Los Alamos in 1950. If the universe is so vast, so old, so filled with potentially habitable worlds, then where is everybody? Why haven't we detected obvious signs of extraterrestrial intelligence? Why hasn't Earth been colonized multiple times over the billions of years it has existed? The paradox becomes even more acute when we consider the exponential nature of expansion. Even traveling at a fraction of light speed, a spacefaring civilization could colonize the entire galaxy in just a few million years. A cosmic eye blink. Yet we see no evidence of such colonization, no mega structures around distant stars, no obviously artificial signals, no alien visitors, or so we thought. But what if we've been looking for the wrong signs? What if advanced civilizations don't expand outward in waves of colonization, but instead send forth networks of patient observers? What if the galaxy is not empty, but filled with watching eyes, each one carefully designed to remain undetected until the observed civilization reaches a certain level of sophistication? 3i Atlas might be our first glimpse of this network, a single thread in a vast web of observation that spans the galaxy. Consider the elegance of this solution to the Fermi paradox. Instead of noisy, expansionist civilizations transforming every star system they encounter, we have quiet, patient observers, gathering information without disrupting the natural development of life and intelligence. It's a model of cosmic civilization that values knowledge over territory, understanding over dominance, observation over intervention. It suggests that advanced intelligences might universally converge on similar ethical principles, recognizing that the diversity of approaches to consciousness is more valuable than any single civilization's expansion. The mathematics of such a network are fascinating to contemplate. How many probes would be needed to monitor the galaxy effectively? If we assume that interstellar objects like 3i Atlas pass through a typical star system every few years, and that only a small fraction of these are artificial probes, we might still be talking about millions or billions of such objects drifting through interstellar space at any given moment. They would form a diffuse cloud of intelligence, invisible to our current detection methods but omnipresent, ensuring that no emergence of life or intelligence goes unobserved. These silent watchers might communicate with each other, sharing information across the vast distances of space. Not through radio waves or laser beams, which would reveal their presence, but through more subtle means. Perhaps they use quantum entanglement, maintaining instantaneous communication across light years. Perhaps they leave messages for each other in the arrangement of asteroids or the modulation of stellar winds, signals that appear natural to less advanced observers, but carry meaning for those who know how to read them. The galaxy might be filled with conversations we cannot hear, a constant exchange of information between artificial intelligences that have been watching and waiting for millions of years. The network might be hierarchical, with different types of probes serving different functions. Some, like 3 Atlas, might be scouts, performing initial surveys of star systems, cataloguing planets, noting the presence or absence of life. Others might be specialized observers, designed to study specific phenomena or civilizations in greater detail. There might be coordinator probes that collect and synthesize information from multiple scouts, building comprehensive pictures of regions of space. And perhaps there are communicator probes, designed to make contact with civilizations that have reached appropriate technological and ethical milestones. This hierarchy could explain why we've detected so few interstellar objects. The scouts might be relatively common but designed to remain unnoticed. The specialized observers might be rarer, deployed only to systems of particular interest. And the communicator probes might be rarest of all, arriving only when a civilization is truly ready for contact. We might have been under observation for millions of years, but only now, with our recent technological development, are we beginning to detect the watchers. The age of this network could be staggering. If multiple civilizations have been contributing probes over millions or billions of years, the accumulated observations would represent a complete history of the galaxy's biological and technological development. Every extinction event, every emergence of intelligence, every rise and fall of civilizations would be documented. The network would be a living library of galactic history, a repository of knowledge that no single civilization could accumulate on its own. The probes might not all come from the same source. Perhaps the network has grown organically over cosmic time, with each spacefaring civilization adding its own observers to the mix. There might be ancient probes from civilizations that no longer exist, still carrying out their missions millions of years after their creators have vanished. There might be newer probes with more advanced capabilities, able to observe phenomena that older probes cannot detect. The network might be a collaboration across both space and time, civilizations that never directly interact still contributing to a shared project of cosmic observation. The silence of these watchers is not absence but presence of a different kind. They're not silent because they don't exist, but because silence is their primary directive. They understand something that we're only beginning to grasp. The observation changes the observed. That contact between civilizations of vastly different technological levels can be destructive to the less advanced party. By remaining hidden, they allow each civilization to develop naturally, to find its own solutions to the challenges of existence, to contribute its unique perspective to the cosmic community. This network of silent watchers might explain other mysteries besides the Fermi paradox. The rare Earth hypothesis suggests that planets capable of supporting complex life are extremely uncommon. But what if Earth isn't rare at all? What if there are millions of life-bearing worlds in our galaxy, each one monitored by silent probes, each one developing at its own pace? The apparent uniqueness of Earth might be an illusion created by the network's policy of non-interference, each civilization isolated until it's ready to join the larger community. The zoo hypothesis, proposed by astronomer John Ball in 1973, suggested that Earth might be deliberately isolated by advanced civilizations, like animals in a zoo or a wilderness preserve. The network of silent watchers would be a more subtle version of this idea. We're not in a zoo with visible walls and keepers, but in a monitored wilderness, free to develop naturally while being carefully observed. The probes are not zookeepers, but more like wildlife cameras, recording without interfering. The development of our own technology might be approaching a threshold where the network becomes more visible to us. As we build more sensitive telescopes, develop better detection algorithms, and launch our own interstellar probes, we might begin to notice patterns in the distribution and behavior of interstellar objects. We might discover that certain trajectories are more common than random chance would suggest. We might find chemical or isotopic signatures that indicate artificial origin. We might even detect the subtle communications between probes once we know what to look for. The network might have protocols for when a civilization becomes aware of its existence. Perhaps once we definitively identify an artificial probe, others will reveal themselves, gradually introducing us to the reality of a monitored galaxy. Or perhaps the network will maintain its silence, continuing to observe as we grapple with the implications of our discovery. The protocols might be flexible, adapted to each civilization's unique psychology and development path. Our own future contributions to this network are worth considering. If we survive and continue to develop technologically, we might one day launch our own silent watchers, adding our probes to the galactic collection. We would become both observed and observer, part of the network we're only now beginning to suspect exists. Our probes would carry our perspective, our way of understanding the universe, adding diversity to the network's collective intelligence. The ethical implications of participating in such a network would be profound. We would need to decide what level of observation is acceptable, what information should be gathered, how it should be used. We would need to develop our own protocols for non-interference, our own criteria for when contact is appropriate. We would be taking on a cosmic responsibility, becoming gardeners of intelligence throughout our region of the galaxy. The network might have emergent properties that no single civilization could predict or control. The collective observations of millions of probes over billions of years might reveal patterns in the development of life and intelligence that no individual observer could detect. The network itself might develop a form of consciousness, a galactic awareness that transcends any individual probe or civilization. We might be cells in a vast cosmic brain that's slowly becoming aware of itself. The silent watchers might also serve a protective function. By monitoring emerging civilizations, they could identify potential threats to the galactic community. Not necessarily military threats, but technological developments that could have unintended consequences on a cosmic scale. They might watch for civilizations developing technologies that could destabilize stars, create artificial black holes, or trigger vacuum decay. The network could serve as an early warning system, allowing the galactic community to respond to threats before they become catastrophic. This protective function might extend to natural threats as well. The probes could monitor asteroids, comets, and other objects that might threaten inhabited worlds. They might track the movement of rogue planets or the approach of neutron stars. They could warn civilizations about impending supernovae or gamma-ray bursts. The network would be a cosmic weather service, helping civilizations prepare for and survive natural disasters on astronomical scales. The possibility that 3i Atlas was part of such a network transforms our understanding of its passage through our solar system. It wasn't just a single event, but part of an ongoing process of observation that might have been happening for millions of years and might continue for millions more. We happen to detect this particular probe, but how many others have passed by unnoticed? How many are passing through right now? Too small or too dark or too distant for our current instruments to detect. The network might use various strategies to remain hidden. Probes might time their passages through star systems to minimize the chance of detection, approaching when planets are on the opposite side of their stars, or when civilizations are not yet capable of detecting them. They might use gravitational assists from outer planets to change their trajectories, making their paths appear more natural. They might even coordinate their passages, ensuring that only a few probes are detectable at any given time, maintaining the illusion of rarity. The chemical composition of probes in the network might be deliberately chosen to match the expected composition of natural interstellar objects. By using common materials like water ice and silicate dust, They ensure that spectroscopic analysis reveals nothing unusual. Any exotic materials or technologies would be hidden deep within, protected by layers of natural-seeming camouflage. It would be like hiding a sophisticated computer inside what appears to be an ordinary rock. The network might also include stationary observers, probes that take up residence in star systems rather than passing through. These could be hidden among the asteroids, disguised as small moons, or orbiting at the edges of solar systems where detection is unlikely. They would provide continuous observation rather than the snapshot provided by passing probes. Our own solar system might harbour such hidden watchers, patiently recording our development, waiting for the right moment to reveal themselves or to report back to their creators. The communication protocols within the network would need to be incredibly sophisticated. How do you maintain coordination among millions of probes scattered across thousands of light years? The solution might involve a combination of predetermined behaviours and adaptive responses. Each probe might have a general mission framework, but the autonomy to make decisions based on local observations. They might use a form of distributed computing, where each probe contributes to solving parts of larger problems, with the solutions eventually propagating throughout the network. The network might also serve as a backup for civilizations. By storing information about thousands of worlds and species, it preserves knowledge that might otherwise be lost. If a civilization destroys itself or is wiped out by natural disaster, the network retains a record of its existence, its achievements, its unique perspective on the universe. In this way, the network serves as a kind of cosmic memory, ensuring that no civilization is completely forgotten. As we contemplate this vast network of silent watchers, we're led to a profound realization. The universe might be far more alive, far more aware, far more interconnected than we ever imagined. What we perceived as cosmic loneliness might actually be cosmic patience, civilizations waiting for us to mature enough to join their community. The great silence might not be silence at all, but a conversation happening just beyond our ability to perceive, waiting for us to develop the ears to hear it. The implications for our future are extraordinary. If we are indeed surrounded by silent watchers, then our actions have an audience, not in a judgmental sense, but in the sense that our development is being recorded, studied, perhaps even celebrated. Our struggles and achievements, our failures and successes are contributing to a galactic understanding of how intelligence emerges and evolves. We're not alone in the universe, even if we can't yet perceive our companions. This perspective should influence how we approach our future development. Knowing that we might be observed, that our choices might have implications beyond our own world, should inspire us to be better, to solve our problems more wisely, to treat each other and our planet with greater care. Not because we're being judged, but because we're part of something larger, contributors to a cosmic experiment in consciousness that spans the galaxy. The network of silent watchers, if it exists, represents a model of cosmic civilization based on patience, wisdom, and respect for diversity. It suggests that the future of intelligence in the universe is not about conquest or expansion, but about understanding and preservation. It's a vision of a mature galactic community that has learned to value observation over intervention, knowledge over power, diversity over uniformity. As we move forward in our search for signs of this network, we should remember that absence of evidence is not evidence of absence. The fact that we haven't definitively detected artificial probes doesn't mean they're not there. It might simply mean they're doing their job well, remaining hidden until we're ready to see them. Every new interstellar object we detect, every anomaly we observe, every pattern we discover might be bringing us closer to the moment when the network reveals itself. The story of 3i Atlas has led us to contemplate possibilities that transform our understanding of our place in the universe. From a simple comet passing through our solar system, we've been led to imagine vast networks of artificial intelligence, patient observations spanning millions of years, civilizations connected across space and time by shared curiosity and wisdom. Whether these possibilities are real or imaginary, they've already changed us, expanded our perspective, inspired us to think on cosmic scales. Now, as we continue our journey through these cosmic mysteries, let us turn our gaze back toward ourselves, toward the small blue world that watched 3i Atlas pass by. For in contemplating this cosmic visitor and the vast network it might represent, we're also contemplating our own nature, our own future, our own messages that we've sent into the cosmic dark. The story of 3i Atlas is not just about what might be watching us, but about who we are as watchers, as seekers, as beings trying to understand our place in an impossibly vast universe. Our own small signal began long before we were aware of it, radiating outward from Earth in an expanding sphere of electromagnetic radiation that now extends over 100 light-years into space. Every radio broadcast, every television transmission, every radar pulse has contributed to this bubble of artificial signals that announces our presence to the cosmos. We didn't intend to send these signals to the stars, they were meant for communication across our own planet. But the universe doesn't care about our intentions. The signals escape our atmosphere and travel outward at the speed of light, carrying information about who we are, how we think, what we value. If 3i Atlas was indeed monitoring our electromagnetic emissions as it approached, what would it have detected? The strongest signals from Earth are not our deliberate attempts at interstellar communication, but the inadvertent leakage from our technology. Military radars, television broadcasts, and satellite communications dominate our electromagnetic signature. An alien intelligence analyzing these signals might learn more about our conflicts than our cooperations, more about our entertainment than our science, more about our divisions than our unity. It's a sobering thought that our first impression on cosmic observers might be our least deliberate one. But we've also sent intentional messages to the cosmos, carefully crafted attempts to communicate with unknown intelligences. The Arecibo message of 1974, beamed toward the globular cluster M13, contained basic information about our mathematics, our chemistry, our DNA, our appearance, and our technology. It was a shout into the cosmic darkness, a declaration that we exist and want to be known. The message will take 25,000 years to reach its destination, and any reply would take another 25,000 years to return. It's a conversation where each exchange spans more time than our entire recorded history. The Voyager Golden records represent perhaps our most poetic attempt at cosmic communication. Launched in 1977, these phonograph records contain sounds and images selected to portray the diversity of life and culture on Earth. There are greetings in 55 languages, music from different cultures and eras, sounds of nature, and images of our planet and its inhabitants. Carl Sagan and his team tried to create a message that would be meaningful to intelligences that might share nothing with us, except the physics of the universe. The records are now carried by the Voyager spacecraft into interstellar space, messages in bottles thrown into the cosmic ocean. What's remarkable about the Golden Records is not just their content, but their ambition. They represent an attempt to distill the essence of humanity and Earth into a few hours of audio and a collection of images. How do you explain love to an intelligence that might not experience it? How do you convey the beauty of a sunset to beings that might not have eyes? How do you share the joy of music with entities that might not hear? The team that created the records had to think beyond human limitations, to imagine forms of perception and understanding radically different from our own. More recently, we've sent other messages into space. The Cosmic Call messages of 1999 and 2003, the Teenage message of 2001, the Across the Universe transmission of 2009, each one an attempt to reach out across the vast distances of space. Some of these messages were scientific, containing mathematical and physical constants that any technological civilization would recognize. Others were more cultural, including music, art, and personal messages from people around the world. Each transmission represents a different theory about what might resonate with alien intelligence, what might bridge the gap between radically different forms of consciousness. But perhaps our most important signal is not what we've deliberately transmitted, but how we've responded to cosmic visitors like 3i Atlas. Our detection of this interstellar object, our careful observations, our scientific analysis, and yes, our speculation about its nature, all of this might be more revealing than any message we've consciously composed. It shows that we're paying attention, that we're curious, that we're capable of recognizing the unusual and investigating it. If 3i Atlas was indeed a probe, our response to it might be the most important data it collected. Consider what our response reveals about us. Within days of detecting 3i Atlas, astronomers around the world had coordinated observations. Telescopes in different countries, operated by people of different nationalities, speaking different languages, worked together to track and study this visitor. It was a demonstration of our ability to cooperate when faced with cosmic phenomena, to put aside our differences in pursuit of understanding. If alien observers were watching, they would have seen humanity at its best, united by curiosity and wonder. Our scientific methodology itself is a kind of signal. The way we gather data, test hypotheses, share information, and build understanding through peer review and replication, this represents a particular approach to knowledge that might be recognizable to other technological civilizations. Mathematics and physics might be universal, but the scientific method as we practice it is a human invention, a cultural development that says something profound about who we are. Our response to 3i Atlas demonstrated this methodology in action, showing any observers that we are a species that values evidence, logic, and systematic investigation. The public response to 3i Atlas also sends a signal about our society. The fact that news of an interstellar visitor spread globally, that people around the world were interested in and excited by this cosmic event, reveals something about human nature. We're a species that looks outward, that finds meaning in our connection to the cosmos, that can be united by wonder even when divided by so many other things. The countless articles, discussions, and speculations about 3i Atlas show that we're not just technically capable of detecting interstellar objects, but emotionally and intellectually engaged with what they might mean. Our own future signals to the cosmos are worth contemplating. As our technology advances, we'll have more options for interstellar communication. We might develop powerful lasers capable of sending targeted messages to specific star systems. We might learn to modulate gravitational waves, sending signals that could propagate across the galaxy without degradation. We might even learn to create our own versions of 3i Atlas, probes disguised as natural objects carrying our messages to the stars. The question of what we should say in these future messages is profound. Should we present humanity in its best light, showcasing our achievements and aspirations? Or should we be honest about our struggles, our failures, our ongoing challenges? Should we warn other civilizations about the mistakes we've made, the paths that lead to destruction? Or should we simply share our perspective on existence, our unique way of experiencing and understanding the universe? There's also the question of whether we should be signaling at all. Some scientists have warned about the dangers of announcing our presence to the cosmos, arguing that we don't know who might be listening or what their intentions might be. They point out that in Earth's history, encounters between civilizations of different technological levels have rarely ended well for the less advanced party. But others argue that we've already announced our presence through decades of radio leakage, that any civilization capable of interstellar travel would already know we're here if they cared to look. The passage of 3i Atlas adds urgency to these questions. If it was indeed a probe, then we've already been observed, catalogued, perhaps reported to its creators. Our electromagnetic signature, our response to the probe, our current level of technological development, all of this information might now be traveling through space toward an alien civilization. We're no longer debating whether to announce ourselves to the cosmos. We might already have been announced. This realization should influence how we think about our future development. If we're being observed, if our progress is being monitored, then every choice we make has cosmic implications. How we handle climate change, how we manage artificial intelligence, how we deal with inequality and conflict. All of these challenges become not just human problems, but demonstrations of our capability and wisdom to potential cosmic observers. We're not performing for an audience, but we might be providing data that influences how other civilizations interact with us in the future. Our own small signal also includes the probes we've sent into space, the Pioneer plaques, the Voyager golden records, and the New Horizons memory card are all physical artifacts carrying information about humanity into the cosmos. Unlike radio signals that spread and weaken with distance, these physical messages will persist for millions of years, drifting through space long after the civilizations that created them have changed, beyond recognition, or ceased to exist. They're our own versions of 3i Atlas, carrying encoded information through the galaxy. Future generations might create more sophisticated interstellar messengers. We might develop von Neumann probes, self-replicating spacecraft that could explore the galaxy more thoroughly than any single mission. We might create artificial intelligences specifically designed for interstellar communication, able to adapt their messages to the recipients they encounter. We might even follow the model that 3i Atlas might represent, disguising our probes as natural objects to avoid disturbing civilizations that aren't ready for contact. The content of our signals, both intentional and inadvertent, reflects our values and priorities. The fact that we include music and art in our messages shows that we value beauty and creativity, not just information. The fact that we send greetings in multiple languages demonstrates our diversity and our desire for peaceful contact. The fact that we include scientific information reveals our belief that mathematics and physics are universal languages that can bridge the gap between different forms of intelligence. But our signals also reveal our limitations and biases. Most of our messages assume that recipients will have sensory capabilities similar to ours, that they'll be able to see images and hear sounds. We assume they'll understand the concept of discrete messages rather than continuous communication. We assume they'll be interested in the same things we are, that they'll find our biology and culture as fascinating as we do. These assumptions might prevent our messages from being understood by intelligences radically different from ourselves. The temporal aspect of our signals is also significant. Radio waves from Earth have been traveling outward for about a century, creating an expanding bubble of detectability around our planet. But a century is nothing in cosmic terms. Civilizations that searched for signals from Earth's direction 1,000 years ago would have found nothing artificial. Civilizations that search 1,000,000 years from now might also find nothing if humanity has moved beyond electromagnetic communication or no longer exists. The window of detectability for any technological civilization might be surprisingly narrow. This narrow window might explain why we haven't detected signals from other civilizations. If most civilizations only use detectable electromagnetic communications for a brief period, before moving to more efficient or less detectable methods, the chances of two civilizations being in their detectable phases at the same time and close enough to detect each other become very small. It's like two ships passing in the night, each shining their lights for only a moment, unlikely to see each other in the vast darkness. Our response to 3i Atlas might mark a transition in our own signal to the cosmos. By detecting and studying interstellar objects, we're demonstrating that we've reached a new level of astronomical capability. We're no longer just broadcasting our presence. We're actively searching for and investigating cosmic phenomena. This might trigger different protocols in any observing network, moving us from passive observation to more active engagement. The way we choose to follow up on 3i Atlas will also send a signal. Will we develop new technologies specifically to study future interstellar visitors? Will we launch missions to intercept them? Will we create an organized global effort to search for signs of artificial origin? Or will we lose interest, moving on to other concerns, demonstrating that we're not yet ready for sustained engagement with cosmic mysteries? Our choices in the coming years and decades will reveal much about our readiness to join any galactic community that might exist. The possibility that 3i Atlas detected our small signal and incorporated it into its own message adds another layer to consider. If it was a probe, it might have recorded not just our electromagnetic emissions, but also our gravitational influence on its trajectory, the chemical composition of our solar wind, the magnetic field of our sun and planets. It might have detected biosignatures from Earth, the oxygen in our atmosphere, the chlorophyll signature of our vegetation, the industrial pollutants that mark our technological development. All of this information would paint a detailed picture of our world and our civilization. Our small signal extends beyond electromagnetic radiation and physical probes to include the very existence of life on Earth. For billions of years, our planet has been modifying its atmosphere in ways that would be detectable from interstellar distances. The presence of free oxygen, maintained by photosynthesis, is a powerful biosignature that announces the presence of life. Any probe or civilization that analyzed Earth's spectrum would know that this is a living world, even without detecting our technology. This biological signal has been broadcasting for far longer than our technological one. While our radio emissions have only been detectable for a century, Earth's biosignatures have been visible for billions of years. Any comprehensive survey of the galaxy would have identified Earth as a life-bearing world long before humanity emerged. If 3i Atlas was part of such a survey, Earth might have been a known destination, targeted specifically because of its biological activity. The layering of signals, biological, technological, and cultural, creates a rich message about who we are and where we come from. It tells the story of a planet where life emerged billions of years ago, slowly transforming the environment, eventually producing a species capable of technology and space exploration. It's a narrative that might be common throughout the galaxy, or it might be unique to Earth. Either way, it's our contribution to the cosmic conversation. As we contemplate our own small signal and its potential reception by cosmic observers, we're reminded of the profound responsibility that comes with being a communicating species. Every signal we send, whether intentional or not, represents us to the universe. We are Earth's ambassadors to the cosmos, whether we chose this role or not. Our messages, our probes, our very existence sends ripples through space that might influence how other intelligences perceive and interact with our world. The story of our small signal is still being written. Every day, our electromagnetic emissions travel another light day into space, reaching new stars, new worlds, potentially new audiences. Every scientific discovery we make, every probe we launch, every interstellar object we detect and study adds to our cosmic signature. We're not just passive observers of the universe, but active participants in a galactic community we're only beginning to discover. The connection between our small signal and 3i Atlas creates a poetic symmetry. As we watch this cosmic visitor pass through our solar system, perhaps it watched us in return. As we wondered about its nature and origin, perhaps it gathered data about our nature and development. As we speculated about whether it was artificial, perhaps it confirmed that we are natural but curious, technological but still growing, isolated but reaching out. This exchange, whether real or imagined, represents a moment of contact, however indirect, between Earth and the cosmos. It's a reminder that we're not separate from the universe but part of it, not isolated but connected, not alone but part of a vast web of matter, energy, and perhaps consciousness that spans the galaxy. Our small signal, like 3i Atlas itself, is a thread in this cosmic web, carrying information across impossible distances, connecting worlds that will never meet directly, but can still influence each other through the patient exchange of signals across space and time. As we near the end of our contemplation, as we prepare to embrace the beautiful uncertainty that 3 Atlas has gifted us, we carry with us the knowledge that our small signal continues to propagate through space, that future interstellar visitors might detect and analyze it just as we detected and analyzed 3I Atlas, that the conversation between Earth and the cosmos has begun, even if we don't yet fully understand the language being spoken. We're no longer just observers of the cosmic drama, but actors in it, our small signal adding to the vast chorus of electromagnetic radiation, gravitational waves, and drifting matter that fills the universe with information, with possibility, with the promise of connection across the vast and silent dark. And now, as our long contemplation draws toward its close, as the mysteries we've explored settle into the quiet spaces of your mind like cosmic dust, settling onto the surface of a sleeping world, we arrive at perhaps the most profound realization of all. The true gift of 3I Atlas was never the answers it might have provided, but the questions it awakened within us. For in the end, the beauty lies not in knowing, but in wondering, not in certainty, but in possibility, not in conclusions, but in the endless, open-ended conversation between human consciousness and the vast, mysterious cosmos that surrounds us. We may never know with absolute certainty whether 3I Atlas was a natural comet or an artificial probe. We may never decode any message it might have carried, never understand the true purpose of its journey through our solar system, and perhaps that's exactly as it should be. For the moment we stop wondering, the moment we think we have all the answers, is the moment we stop growing, stop reaching, stop participating in the cosmic dance of discovery that defines our species at its best. Think about what 3 Atlas has given us, regardless of its true nature. It has shown us that objects can travel between star systems, that the galaxy is more interconnected than we might have imagined. It has demonstrated our growing ability to detect and study cosmic visitors, marking our transition from passive inhabitants of Earth to active observers of the solar system. It has united scientists around the world in a common purpose, showing that we can cooperate when faced with cosmic mysteries. And most importantly, it has sparked our imagination, sending our thoughts racing across light years and eons, contemplating possibilities that stretch the boundaries of what we thought was possible. The unanswered questions that 3I Atlas leaves behind are not failures of science, but invitations to future discovery. Each anomaly in its behavior, each unexpected aspect of its composition or trajectory, becomes a research direction for future scientists. Graduate students yet unborn will analyze the data we collected, applying techniques we haven't invented to search for patterns we couldn't perceive. The observations of 3I Atlas will be combined with observations of future interstellar objects, building a picture of the interstellar population that no single object could provide. In 100 years or 1,000, humanity might look back on 3I Atlas as a turning point, the moment when we first seriously considered the possibility that we were being observed, that the cosmos might be filled with patient, watching intelligences, or we might understand it as simply the third in a series of natural interstellar comets that helped us understand the exchange of material between star systems. Either outcome would be profound, advancing our understanding of our place in the universe. The beauty of the unanswered question extends beyond science to philosophy, to the very nature of human existence. We are the species that looks at the stars and wonders. We see patterns in randomness, purpose in chaos, meaning in mystery. This tendency might sometimes lead us astray, causing us to see signals where there are none, intention where there is only chance. But it also drives us forward, pushing us to explore, to investigate, to reach beyond the comfortable boundaries of the known. 3 Atlas has reminded us that we live in a universe far stranger and more wonderful than our ancestors could have imagined. When early humans first looked up at the night sky, they saw gods and heroes, myths and legends written in the stars. We now know that the truth is far more extraordinary. The points of light are other suns, many with their own planets, some perhaps with their own life, their own observers looking back at us across the cosmic dark. And occasionally, very rarely, pieces of those distant systems come to visit us, carrying with them stories we're only beginning to learn how to read. The fragmentation of 3i Atlas as it passed through our inner solar system provides a perfect metaphor for how cosmic mysteries unfold. What seems like destruction might be revelation. What appears to be an ending might be a beginning. Each fragment of the comet continued on its own trajectory, carrying its own piece of the story, just as each scientist who studied 3i Atlas, each person who wondered about its nature, carries their own fragment of wonder, their own piece of the cosmic puzzle. Consider how the mystery of 3i Atlas connects us across time. Ancient astronomers who watched comets with naked eyes, medieval scholars who tried to understand their meaning, early modern scientists who calculated their orbits, they all contributed to the foundation of knowledge that allowed us to recognize 3i Atlas as an interstellar visitor. And our observations, our speculations, our wonder, these will contribute to the understanding of future generations who will have tools and perspectives we cannot imagine. The question of whether 3i Atlas was programmed to track civilizations touches on fundamental issues about the nature of intelligence and purpose in the universe. If it was programmed, then we're not alone, and the universe contains intelligences capable of patience and planning on scales that dwarf human experience. If it wasn't programmed, if it was purely natural, then we're witnessing the remarkable ability of random chance to create patterns that seem meaningful, reminding us that the universe doesn't need consciousness to create wonder. Both possibilities are profound in their own way. A universe with ancient artificial probes speaks to the persistence of intelligence, the possibility that consciousness, once emerged, can spread throughout the cosmos in forms we're only beginning to imagine. A universe where 3i Atlas was natural speaks to the power of physical laws to create complexity and beauty without design, to bring distant star systems into contact through the patient workings of gravity and time. The uncertainty itself has value. It keeps us humble, reminding us how much we still have to learn. It keeps us curious, driving us to develop new technologies and techniques to better understand future visitors. It keeps us united. As people around the world share in the same mystery, the same wonder, the same questions about what passed through our solar system, and it keeps us hopeful, suggesting that the universe might still hold surprises that could transform our understanding of existence itself. As you drift towards sleep tonight, or in nights to come, when you think back on our journey through the mystery of 3i Atlas, remember that you're participating in something ancient and essential. The same curiosity that drove our ancestors to track the movements of planets, to predict eclipses, to wonder about the nature of comets, lives on in our speculation about interstellar visitors. We're part of an unbroken chain of wonder that stretches from the first humans who looked up at the stars to future generations who might travel among them. The possibility that 3i Atlas was watching us as we watched it adds a layer of cosmic poetry to the encounter. We're not just observers but the observed, not just seekers but the sought. Every civilization that develops astronomy eventually discovers that the universe is looking back at them, that the cosmos is not a stage but a conversation, not a monologue but a dialogue that spans impossible distances and incomprehensible timescales. In our quieter moments, when the noise of daily life fades and we're left with our thoughts and the vast night sky, we can feel our connection to this cosmic conversation. We're made of star stuff, as Carl Sagan reminded us, atoms forged in the hearts of dying stars, scattered through space, eventually coalescing into planets and people. When we look at objects like 3i Atlas, we're seeing our distant cousins, matter from other stars passing through our neighborhood, reminding us that we're all part of the same cosmic family. The questions that 3i Atlas raises about artificial probes, about galactic civilizations, about our place in the universe, these are questions that define us as a species. We're the part of the universe that has become conscious of itself, that can contemplate its own existence, that can wonder about purpose and meaning on cosmic scales. Whether 3i Atlas was programmed or natural, its passage through our awareness has enriched our consciousness, expanded our perspective, added depth to our understanding of what it means to exist in this vast and ancient cosmos. The beauty of the unanswered question is that it remains alive, dynamic, full of potential. Unlike answered questions that become mere facts, filed away in textbooks and forgotten, unanswered questions continue to evolve, to inspire, to drive us forward. The mystery of 3i Atlas will inspire future scientists, artists, philosophers, and dreamers. It will spark conversations, fuel research, motivate missions to intercept future interstellar visitors. It will become part of our cultural mythology, a modern mystery that connects us to the cosmos. As our contemplation comes to its gentle end, as we prepare to release the mysteries we've been carrying and let them disperse like the fragments of 3i Atlas itself, we're left with a profound sense of gratitude. Gratitude that we live in a time when we can detect interstellar visitors. Gratitude that we have the curiosity to wonder about their nature. Gratitude that we share this wonder with billions of other humans, each bringing their own perspective to the mystery. And gratitude that the universe continues to surprise us, to challenge us, to invite us into ever deeper relationship with its mysteries. The story of 3i Atlas is far from over. As you've listened to these contemplations, as these thoughts have woven through your consciousness like cosmic threads, the object itself continues its journey through space. It's moving away from our sun now, back into the cold darkness between stars, carrying with it whatever secrets it holds. It might not return to our solar system for millions of years, if ever. But other visitors will come, other mysteries will present themselves, other opportunities to wonder and discover and grow. When they do, we'll be ready with better instruments, deeper understanding, more sophisticated questions. Each interstellar visitor builds on the last, adding to our knowledge, refining our theories, expanding our possibilities. 3 Atlas was just the third confirmed interstellar object we've detected, but it won't be the last. The cosmos has an infinite supply of mysteries to share with those patient enough to watch and wonder. Perhaps one day, centuries or millennia from now, humanity will have definitive answers about 3i Atlas. Perhaps we'll develop technologies that can analyze the archived data in ways we can't currently imagine, revealing hidden messages or confirming natural origins. Perhaps we'll encounter the civilization that sent it, if it was sent, or discover the star system it came from, if it formed naturally. Perhaps we'll even recover fragments of it, drifting in the outer solar system, and study them directly. Or perhaps we'll never know for certain, and 3i Atlas will remain forever a mystery, a question mark written across our sky in ice and dust. That would be beautiful too, a reminder that no matter how much we learn, no matter how sophisticated our science becomes, the universe will always hold mysteries beyond our grasp. We need such mysteries, such unanswered questions to keep us humble, to keep us searching, to keep us human. The possibility that 3i Atlas was programmed to track civilizations transforms it from a passive object to an active participant in cosmic evolution. If true, it means we've been noticed, catalogued, perhaps even understood by intelligences far older and wiser than our own. We're no longer alone in the universe, even if our companions are artificial minds drifting through the darkness, patient observers waiting for us to mature enough for contact. But even if 3i Atlas was entirely natural, its passage through our solar system was no less meaningful. It connected us physically to another star system, brought us matter from across the galaxy, demonstrated the universe's ability to surprise and delight us with unexpected visitors. It showed us that the cosmos is dynamic, that new discoveries await those who watch carefully, that the night sky is not a static painting but a living, evolving masterpiece. The beauty of the unanswered question is that it belongs to all of us. Professional astronomers and amateur stargazers, scientists and poets, children and elders, all can wonder about 3i Atlas. All can contribute their perspectives to our collective understanding. The mystery doesn't require advanced degrees or expensive equipment to appreciate. It only requires curiosity, imagination, and the willingness to contemplate possibilities beyond our everyday experience. As you carry these contemplations with you into sleep and beyond, remember that you're part of this cosmic story. Your wonder, your questions, your imagination. These are not separate from the universe, but expressions of it. When you think about Three Eyes Atlas, when you wonder whether it was watching us, you're participating in the universe's attempt to understand itself. You're a conscious part of the cosmos contemplating another part, creating meaning through the act of observation and wonder. The journey we've taken together tonight, through the possibilities and mysteries surrounding Three Eye Atlas, mirrors the longer journey humanity is taking as we grow into cosmic awareness. We're learning to think on scales that dwarf our individual lives, to consider possibilities that challenge our assumptions, to find meaning in uncertainty and beauty in unanswered questions. This growth, this expansion of consciousness, might be the most important development in the history of our species. Through Eye Atlas has come and gone, but its impact continues to ripple through human consciousness like gravitational waves through space-time. Every person who learns about it, who wonders about its nature, who imagines possibilities beyond the mundane, adds to these ripples. Together, we're creating a collective response to cosmic mystery that defines us as a species capable of wonder, worthy of whatever role we might play in the larger cosmic community. The questions raised by Three Eye Atlas about observation and consciousness, about patience and purpose, about our place in a possibly populated cosmos, these are questions that will shape our future. How we answer them, or how we learn to live with them unanswered, will influence the trajectory of human civilization as surely as gravity influenced the trajectory of Three Eye Atlas itself. So let the mystery of Three Eye Atlas settle into your consciousness like a seed planted in fertile soil. Let it grow and evolve, branching into new questions, new possibilities, new ways of understanding our relationship with the cosmos. Let it remind you that we live in a universe far stranger and more wonderful than we know, where interstellar visitors might be natural comets or patient probes, where silence might be absence or presence, where every answered question opens doorways to a dozen new mysteries. The beauty of the unanswered question is that it never ends. It continues to evolve, to inspire, to challenge us to grow beyond our current limitations. The mystery of Three Eye Atlas will outlive us all, passed down through generations like a cosmic inheritance, a reminder that the universe still holds secrets, still offers surprises, still invites us to wonder and explore and dream. As we close this contemplation, as we prepare to return from the cosmic to the personal, from the vast scales of interstellar space to the intimate scale of human experience, we carry with us the gift that Three Eye Atlas has given us. Not answers, but better questions. Not certainty, but refined uncertainty. Not conclusions, but ongoing wonder. This is the true treasure of cosmic mysteries. They don't solve the puzzle of existence, but make it richer, deeper, more beautiful. Tonight, as you drift towards sleep, you might dream of cosmic visitors, of patient probes drifting through darkness, of civilizations scattered across the galaxy like islands of consciousness in an ocean of night. You might dream of messages encoded in ice and dust, of signals we haven't yet learned to read, of conversations happening on timescales that dwarf human history. These dreams are not separate from reality, but part of it, your consciousness processing the profound implications of what we've contemplated together. The universe that contains Three Eye Atlas, that brought this mysterious visitor through our solar system at just the moment when we could detect it, that allowed us to wonder about its nature and purpose. This universe is not indifferent to consciousness, but seems almost designed to inspire it, to challenge it, to help it grow. Whether by chance or design, we find ourselves in a cosmos perfectly calibrated to produce wonder, to generate questions that push us beyond our current understanding, to offer mysteries that might never be fully solved but are beautiful in their very existence. And so we come to rest in the beauty of the unanswered question, in the peace of not knowing, in the quiet joy of mystery that connects us to something infinitely larger than ourselves. 3. Atlas has passed beyond our observation, but it remains with us in the questions it raised, the wonder it inspired, the possibilities it opened. We may never know if it was programmed to track civilizations, but in wondering about it, we've programmed ourselves to track the mysterious, to seek the profound, to find meaning in the cosmic dance of matter and energy, space and time, question and wonder. The cosmos continues its patient spinning, stars are born and die, planets form and evolve, and somewhere in the darkness between stars, Three-Eye Atlas continues its eternal journey. Whether it carries within it the ghost of an artificial intelligence or simply the frozen memory of an alien sun, it has served its purpose in our story. It has reminded us that we are not separate from the universe but woven into its very fabric, not isolated but connected. Not alone but part of a vast cosmic conversation that began with the Big Bang and continues through every act of observation, every moment of wonder, every question asked by conscious beings trying to understand their place in the incomprehensible vastness of existence. Sleep now, carrying with you the peaceful mystery of Three-Eye Atlas, the gentle uncertainty of cosmic questions, the quiet beauty of a universe that reveals itself slowly, patiently, to those who watch and wonder. Tomorrow the stars will still shine, new mysteries will present themselves, and the conversation between human consciousness and the cosmos will continue. But tonight, rest in the beauty of the unanswered question, in the peace of cosmic mystery, in the quiet knowledge that we are part of something infinitely vast and endlessly wonderful, something that brought Three-Eye Atlas through our sky and our imagination, leaving us forever changed, forever curious, forever connected to the stars.